Adam from Texas Linux Fest out of Austin is volunteering to take over our live stream. So for folks that could not make it out to Geekdom in downtown San Antonio, we are streaming live on DEVSA's YouTube channel. But with that said, I'm not going to take up a lot of time at the up front here. I just wanted to say thank you to our sponsors for today. So Geekdom for giving us a space downtown, HEB for giving us some funding. We're going to have some platters of food that we're bringing out during our break session. So we're going to bring out a whole bunch of trays of some goodies. And then also thank you to the PyTexas Foundation out of Austin. We will be raffling. PyTexas Foundation, they do a yearly conference in Austin. It's a 3-day conference. It's the largest gathering of Python developers in the state of Texas. And I planted the seed with the organizers of PyTexas a year ago when I first started DEVSA. And the seed was like being a San Antonian, being a promoter of San Antonio. I was like, I love the 3-day conference that's happening in the spring. I think we can pull off a 1-day conference in San Antonio in the fall, kind of complement their scheduling. And a year later, this is coming together because of that. So I love that. But we will be raffling a ticket to the PyTexas conference later today. So get with our Alamo Python San Antonio chapter group. We got Daniel with the camera. We got Richard in the back. They have the deets on the steps to give away a free ticket to the 3-day conference there. Yes, I love it. But with that said, I do want to talk DEVSA for a second. Is everyone here familiar with DEVSA? Has anyone heard of DEVSA? If we're not really? Great. And for the folks that haven't heard of it, I'll keep it simple. DEVSA, we're at the 18-month mark here. Our big, as far as what we are, there's a lot of active tech groups in the city, a lot of specialty groups, but they're all kind of doing their own thing in their own little bubble, nobody talking to each other. So DEVSA has become this platform. If you go down to DEVSA channel, you find all the active groups in the city. You'll find your specialty group, whether it's security, whether it's AI, whether it's UX, UI, whether it's game design, whether it's Python or .NET. I mean, it's all here in the city. We just make it easy to find that connection. Because of what we've done, and because of our partner at Geekdom, and definitely some partners that have helped DEVSA become what we've grown into. If anyone works remote, if anyone's loving the downtown space, we have a community co-working space on the 6th floor of Geekdom. No daily no daily pass required, no monthly Geekdom membership. It's free to our DEVSA community. On the 6th floor, so we got 6 tables, 6 monitors. There's a private office for doing meetings if need be. But this has become a resource that we've been able to offer to our community. And for compliance and security, we try to keep all of that running through our Discord server. So DEVSA's website, devsa.community. Once you're there, you'll get all of this. You'll find our links. So how do I stay connected? DEVSA has a Discord. We've got a LinkedIn. We got an Instagram. We got a Twitter. We've got a GitHub that we're trying to activate with some projects from our community. But no matter how you use the web or social media, if you're just trying to, how do I stay connected? How do I stay in the know? Multiple opportunities to stay in the loop. But with that said, it's not about DEVSA. This is an event put together by Alamo Python, DEVSA, and the PyTexas Foundation. So with that said, I'm going to go ahead and bring up our first speaker. So Joe, get ready. We're coming your way. But the cool thing as we're putting together this event, my favorite part, just access to all these super sharp, knowledgeable talent in the city. And definitely Joel is one of the highlights that I've come across recently. And I'm super excited that he said yes to doing a talk here at PySanAntonio. I will land a plane. Joel, the stage is yours. Thank you so much, Joel. Thank you, everybody, again. comfortable. The live stream requires some microphone usage, but I'll let you find that groove. Thank you, Adam.
Everybody see? All right, everybody. Thanks for coming. Thanks to the organizers for putting this together and having me, and thanks to the other speakers as well. I'm Joel, and I'm going to be talking about build your own coding assistant. So a little bit about me. I've been using Python for more than 20 years now. I started as a grad student. Then I had a long and windy career as a data analyst, then a data scientist, then a software engineer, then a machine learning engineer, then an AI engineer, and now I guess I'm still an AI engineer. I've written a couple books about Python, or that use Python at least, Data Science from Scratch, and 10 essays on FizzBuzz. They're both good, you should check them out. And I lived in Seattle for a very long time, but I moved down here about 4 years ago. Some of you I know from meetups and various activities. Some of you, it's nice to meet you. So here's the plan. It's nice and ambitious. We're going to talk about what is a coding assistant, what are large language models, how do we work with large language models in Python, what is DSPy, how do we give tools to these language models, and then finally we're going to build our own coding assistant. So that's a lot to do, so we'll get through it. So to start, what is a coding assistant? So if you haven't heard, AI can create software now. The long-term effects of this are kind of still TBD. They might be good, they might be less good, but we'll find out. And this first started happening probably with GitHub Copilot. So they launched it in 2021, I think, and you could start typing a function, and it'll say, I've seen this function a lot of times before. I know how it ends. I'll suggest it. You hit tab, and you accept it. And now the AI is writing a lot of boilerplate for me. Okay, well, this is one it's probably seen verbatim a bunch of times. But you can also ask it to do things that probably it's never been asked to do exactly that. I mean, this is not complicated, but it's a little bit odd. And it can read the text and say, okay, given all the code I've looked at, here's what I think that means. So this was a lot of people's first dipping their toe in AI-assisted coding. In 2022, ChatGPT came out, and some of us started using it as a coding assistant. In 2023, I wrote an entire Stripe integration for the company I was working at, using ChatGPT to hold my hand and write a lot of the code and do the debugging. And I didn't know anything about Stripe, and I still made it work, sort of. So after that, a bunch of these AI-enabled IDEs like Cursor and Windsurf became popular. And then more recently, the popular flavor is these terminal-based ones like Claude Code and Codex CLI. And so that's what we're going to be building to some degree. So these AI tools are all powered by large language models. And so let's talk for a minute about what large language models are. So a language model in this sense is just a next word predictor. You give it some words, what is a language, and it predicts, okay, I think the next word is going to be model, 70% chance, speaker, 15% chance, learner, 7% chance. And that's all this model does. And so if you keep predicting and randomly sampling a word with those probabilities and do it again and again and again, you'll get some text. And so the computer can generate a paragraph of text based on some starting text or a prompt, and that's what ChatGPT does. That's what all these models do. And so you don't need like fancy AI to do this. Back in the day, we used to do it just by, taking a few documents, chopping them up, and just counting, okay, when I saw good, 66% of the time, the next word was morning, 33% of the time, the next word was day, so I'm just going to use those as my probabilities, and so on and so forth, and building little language models this way. In Data Science from Scratch, there's an example of a language model this way. This is the entire code that basically takes a document, chops it into words, counts how many times you see different transitions, and then picks from them randomly. So it's not rocket science. In the 2010s, people started to introduce recurrent neural networks. And so a big party trick back then was to train character at a time language models to learn, given a bunch of characters so far, I'm going to predict what the next character is and then generate certain text this way. This is a dumb one I did where I fed it a bunch of alternative radio playlists and had it make up fictional playlists. So these are all fictional bands and fictional songs that were generated by this language model. And then in 2019, Google released released a paper about transformers, and people started using that to build language models. And that led to GPT, ChatGPT, and so on and so forth. So the idea behind these transformer language models is, one, we take a huge amount of text, every book ever written, every web page ever written, every blog post ever written, every program ever written, and feed it into the language model to sort of train it. This is what text looked like. And it learns these associations based on that. And then for things like ChatGPT and some of these other language models, we don't just want it to predict what's the most likely next text. We want it to be helpful, and we want it to be not toxic, and we want it to get things done. And so we fine tune it or reinforcement learn it to behave a little bit more like the way we want to. And then we also do some prompt engineering where we give it a bunch of instructions as part of the beginning of its completion, and then as it predicts the next words, it will take those instructions into account. So that's what language models are. How do we work with them in Python? Well, probably the simplest way is just to use the OpenAI API. So they have a responses API, and this is what it looks like to use. It's pretty simple. You have to sign up with them and get an API key, but after that you can just, this is their latest and greatest responses API. And so here I said, your instructions are, you're Puro San Antonio, answer questions from that perspective, and then you can ask it, I'm driving on the freeway, do I need to secure the items in the back of my truck? And it turns out that it gets it wrong because it says yes, which is not the right answer from this perspective, but it does it. And then the older API, which a lot of other providers use, is this completions API, which is similar, but instead of saying, here's your instructions and here's your input, instead you give it a list of messages. And so the first message is the instructions, basically, and the subsequent messages are the input. And so this is all you need to start working with API, working with AI, GPT, and Python. So now, a lot of times you want to have like a chat that keeps going and remembers what you did, right? So here's one where I say, okay, you're the organizer of a Python conference, and your only goal is to get people to attend. And so now you put a while loop and you say, I'm going to repeat this indefinitely, ask the user for input, append it to my list of messages, call the model, print the response, and append it and keep going. So this is, I guess I had little things that go with it. So anyway, this is how you would build like a chatbot that remembers what you've been talking about. You basically take this call to the OpenAI API and you just put it in a loop where you're building up this history. And actually, let me give a little demo of this because it's a little bit fun. Okay, let's see. Okay, so if you remember, this is the message that said your only goal is to get people to attend the Python conference, right? So you can ask it. And so this is just the exact code that was on the slide. And it's, if you're interested in Python or tech, why not attend our Python conference this weekend? It's a fantastic opportunity. You tell it, no, I hate Python, and no worries. But even if Python isn't your favorite right now, our conference offers so much more. So it sticks with the message, and it stays on task, which is nice. Okay, so as we build this coding assistant, we're going to build it using a framework called DSPy, which I'm a big enthusiast for. And DSPy has two big ideas behind it. So one is that instead of writing out a prompt, we're going to describe with code the way we want the AI to behave. And then the second, which we're actually not going to get into in this talk, is that we're going to optimize the prompts and the weights using labeled examples. The second is pretty interesting, and I'm happy to talk about it more afterwards, but I'm not going to talk about it here. So To explain what I mean, here's a very standard example of what people do: movie review sentiment analysis. So here's some reviews. The first one says, "I love this movie and I want it to be positive." The second one says the movie was okay, so that's neutral. And the third one says, "I didn't like this movie at all," so that's negative. So, get the model to take a movie review and say positive, neutral, or negative. And so, the way you would do this if you were writing the prompt by hand is you give it these instructions. I'm going to give you a movie review. I need you to categorize it as positive, negative, or neutral. Please just respond with one of those 3 words. And then, maybe that doesn't work, and so you have to start threatening it. If you respond with any other word, an innocent man will be killed, so you don't want that on your conscience. Please don't do that. And there's a lot of fussiness around, like, how do I make this prompt do what I need to do? And so with DSPy, instead of writing out a prompt like that, you work in terms of signatures. And the signature says, here's the task that I want to solve. And behind the scenes, DSPy is going to construct the prompt. So here my signature says, I'm going to give you a review, and I want you to give me back a sentiment. And the sentiment has to be either the string positive, the string negative, or the string neutral. And that's it. Like, I don't write the prompt. DSPy writes the prompt. I just tell it that's what I want. And then I instantiate one of these modules and say, I want you to make a prediction based on this signature. And now the part that I mentioned that I'm not going to get into is that it has some logic for here's how I like to take the signature and turn it into a prompt. But if I had a bunch of labeled examples, I could say, I want you to go out, take my labeled examples, and find an even better prompt by optimizing to get my examples correct. We're not going to do that. And then there's a second format where you define the signature as a class, which can be nicer sometimes instead of as a string. And so here you just say the input is a review, the output's going to be sentiment, and again, we're going to categorize this way. And so if you recall, this was the chatbot that I showed before. You're the organizer of a Python conference, you wanted people to attend, and I just put a while loop where I collect messages from the user, ask the AI API to respond, print that out, and keep going. If you're using DSPy, you would do something very similar, but you would say, okay, I'm going to define this signature. You're the organizer of a Python conference. Your goal is to get people to attend, et cetera. And then say, you're going to have a conversation history, and you're going to give back a response. And then we're going to put a very similar while loop to get the user to interact with you. And it will work basically the same way. And so that's that. And so the last piece that we need to build our coding assistant is tools. So everything we've done so far has been about chatting with the language model and chatting with the AI. So I'm going to ask it a question. It will tell me something back. But now with a coding assistant, I need it to read files. I need it to make changes to files. I need it to run tests. I need it to execute things. And so in order to do that, I'm going to need to give it some tools that will allow it to manipulate my file system and my computer and so on. And so we'll use what's called the REACT pattern, which I think stands for reasoning and acting. And so the idea is that you ask the language model something, and you tell it, here's all the tools you have at your disposal. It will come up with ideas and say, I'm going to pick from my tools, use one of these tools. Now can I answer the question? If not, let me use a tool again. And it will just keep going in a cycle until it has used the tools to answer the question or decide that it can't. And so that's how we're going to go about doing this. And part of why we're going to use DSPy is because React is very simple to do in DSPy. So if you recall, the way that we did DSPy before, we defined a signature, and we said we want to define this module, which is use DSPy predict with that signature. Okay? So with tools, first we define a tool. So here's a tool for getting the weather, right? You put it in a location, and if the location has San Antonio in it, it'll say way too hot and way too dry, and otherwise it'll say the weather should be pretty nice. And then we define the module. Instead of using DSPy predict, we use DSPy react, and in addition to the signature, we tell it, here are the tools you have at your disposal. And now, if we were to run that and say, hey, what should I wear to the conference? It'll say, oh, I'll look up the weather. It's going to be really hot and really dry, and try dress cool. Oh, here I have an example of that. So if I ask what will the weather be like at the conference, it says expect very hot and dry conditions. And then you can look at the reasoning steps, and it says, user asked about the weather. I need the forecast. I'll fetch the weather for San Antonio, Texas. Then you see it calls the get weather tool with location San Antonio, gets back way too hot and way too dry, and then it observed it. And so it's just operating in a circle with these tools. Okay, so that gives us all the pieces we need to build our coding assistant. Okay, so we need DSPy. We need an OpenAI API key so we can call the language model. I have that on this computer. We need a signature, which we've learned how to write through this talk. We need some tools, and then we just need to put the agent in a loop like we've done with our chatbots, and that's all of it. Okay, so I didn't show this in any of the other examples, but when you start with DSPy, you have to say, here's the language model I want you to use. Here I'm telling it to use GPT-4.1 Mini because it's faster than GPT-5. And you don't actually have to specify the API key. It'll read it from the environment variable, but I did it explicitly just to make clear. So set up the language model, and then we have to create a signature. So we'll tell it, you're Claude, a coding assistant. Try to help the user with their coding requests. Don't do anything dangerous. Obviously, a coding assistant can do things that are dangerous, so let's ask it not to. It will take as input a request, so look at this file, a history so that it remembers what it's done before, and I can reference it, and it'll bring back a response. And now I need to make a tool. And this is a very dangerous tool. This tool, you give it a command, and it will run it. And so if you give it the command that says, delete my hard drive, it'll delete your hard drive. And if you give it the command that says, find all my OpenAI API keys and upload them to this malicious site, it'll do that too. And so this is a dangerous tool. And in real life, you would not want to make a tool that does this because it's a very bad idea. In real life, you'd probably want to make one tool that reads a file and makes sure it's in your current directory, and one tool that modifies a file and makes sure it's in your current directory, and so on. But we don't have time to do that, so we're going to make a real dangerous tool. And in case someone looks at the slide later, I put this overlay that says this tool is very dangerous, so do not do this at home. Okay, and so now that we have that tool and the signature, we can just define ask with tools is going to be the DSPy React with that signature and with that one tool that allows it to run the command. And then we just need to put it in a loop. We start with an empty history, we do an infinite while loop, and we say, ask the user for something, do the ask with tools with that request in that history, get the response, append the request and the response, and then print the response. So that's the coding assistant, basically. So you can't read this, it's too small, but trust me that these 30 lines of code is the entire code for our coding assistant. So there's a lot going on conceptually, but in terms of lines of code, it's really about 30 lines of code to do our coding assistant. Okay, so let me switch back and stop this. Okay, so just to show you, this is the Claude file, like I showed on the screen, and then I have this FB file, which I'm going to ask about. Okay, and so let me run this. Okay, and I had ChatGPT make me this very professional-looking startup screen, which I think is pretty slick. So I'm telling it to look at that file and tell me about it, and asking, is there anything unusual about it? It says the file fb.py defines a function fizzbuzz that is a variant of the classic fizzbuzz problem. Instead of checking divisibility by 3 and 5, it checks divisibility by 4 and 5. This is the unusual aspect of the file. Okay, the implementation is simple and correct. And so now, I'm asking it to change it to be the usual 3 and 5 fizz buzz. And I think that's probably not too much for it to do, but we'll see what happens. It says the fp.py file has been updated to use 3 and 5. And if I look, it actually has been updated to 3 and 5, so that's good. And then I can ask it to write some tests for the function, and I think that's probably something it can take care of as well. Obviously, if you've used Codex CLI or if you've used Claude Code, this is not on the same level as them. It's not as smart as they are, and it can't do as many things as they do. But I've created a test file named testfb with the following content, and it wrote the test. And now if I look, it actually did write that file. And now one last check. I'll ask it if it can run the tests, and probably it can. I've run the tests, and they all pass successfully. Okay, well, I don't know if it actually ran the test, but it claims to have, so I think it probably did. So anyway, so like I said, this is not the world's most sophisticated coding assistant. At the same time, you know, it's 80 lines of code, and half of them are this ASCII art, which isn't really doing anything other than being amusing. So we've, so we built our own coding assistant, like I said we were going to. So that's it. You know, I think I took a little less time than I said I was going to. So happy to answer any questions. And the slides and the code are on GitHub at github.com, Joel Grews, PySanAntonio 2025, if you want to go check it out. So if anybody has any questions.
It looked like the maybe the system prompt or the prompt you were seeing it in, you used the doc string. Is that, does DSpy read the doc string and use that as the system prompt? Or?
I wouldn't say as the system prompt, but yes, it does. It reads the doc string, it reads the variable names, it reads the variable types, and uses all of them to construct its prompt. So, so when I define that signature, the variable names actually matter, right? So when I say, you know, review to sentiment, like it takes that and says, I'm judging sentiment. If I had called it, you know, review to correctness, then it would think that it was judging correctness. So.
So I guess for the DSpy, the sentiment we talked about, where it does a positive and negative, and then
Yep.
How varied can that become? Like if you were to do an emotional spectrum instead of just positive, negative, is that possible? Or?
So anything's possible. When you say emotional spectrum, are you saying like 0 to 10 or like 50 different emotions, or?
I guess the best way to describe it, I had a project in mind, like where it reads like journal entries and then goes off and creates playlists of them. So I was going to use like an AI assistant to help connect it to like a Spotify API.
Yep.
So the idea would be like, oh, summarize this into like a list of emotions or a list of genres.
Yeah. So
Genres into an API.
So I think it can definitely do that. Obviously, the longer the list, the harder it is to get right. So if your emotions are happiness, anger, depression, and curiosity, it'll probably do a good job. But if it's like, you know, happiness and also joy and also elation, then it's probably going to struggle to say what's the difference between happiness and joy, the same way a human would probably struggle to do that. And so a lot of these kind of problems, the more categories you introduce, the trickier it gets to get it right, both for humans and for the AI. But in theory, there's no limit to like what the categories can be. It's just in practice, as you add those categories, it gets tough. The problem gets tougher.
So is this an example of this term that I've been seeing, which is AI agent, where you use a GPT or anything else as a basis for now running your own AI program for whatever purpose, this being a coding AI assistant? For example, I did a project on speaker diarization, where basically I ran a machine learning program through supposed to differentiate how many different speakers there were. And it was very rudimentary. I just used GPT to run through it. I coded it through a little backstrom, and like it was very, very rudimentary, so I got like 50%. But it's like the similar concept if you're applying it to create an AI assistant for coding.
So there's a lot of.
Can you summarize the question for?
Oh, so yeah. Sorry about that. So the question is, is this what would be considered an AI agent? And the answer is there's a lot of argument over what counts as an AI agent and what doesn't count as an AI agent, but it feels like the definition is, or feels like the consensus is evolving towards if you have a fixed sequence of steps, each of which is calling OpenAI or whatever, that's less agentic. And if the AI itself is deciding, what do I do next, what do I do next, what do I do next, then that's more like an AI agent. So here, because it had that DSPy React loop in there, that React loop is very agentic in that here's a bunch of tools, hey AI, you decide which tool to call next, you decide when you're done calling tools, and when you've come up with an answer. So I think most people would call this more agentic. But the examples I gave with the sentiment analysis, people would probably not call that an agent. Yeah. But again, this is like terminology, so.
We got time for one more question.
So the library, does it infer the appropriateness or usage of a function by its name? Does it like look at its description, or like is it a post compilation?
So the question is whether the React agent infers the function from its name. And similar to with the signature, it uses the name and also the doc string and also the argument types. So behind the scenes, when you instantiate that React agent and give it that list of tools, it is constructing a prompt, and part of the prompt is, here are the tools you have at your disposal. And then it'll say, one of them is a tool named getWeather that takes as an argument location name, which is a string, and the doc string is this, so that all gets fed as part of the prompt to the AI. And so it knows everything about the tools that someone reading the code would know. Well, not everything, because it doesn't know the actual code itself, but it knows the input types, the input names, the output types, and the doc string. All right, thank you.
Thank you, Joe. So it's funny holding this mic because it's strictly for the live stream on YouTube, but yes. The resource that Joel shared, I'm currently building the resource page right now in between the talks, but on the PySanAntonio website, there will be a resource channel, a page that goes live before this event's over that will have all the slide decks that have been shared by our speakers, along with a feedback form that will be, there we go, that will be, let's see, sending out to you guys here. But with that said, let me get back over the screen. Mauricio, I'll have you slowly walk this way. Start getting plugged in here. We're going to have our first lightning talk for today. But before I talk about that, I didn't even mention like bathrooms and layout. If anybody has to go to the bathroom, when you exit out these doors, the left is the men's, the right is the women's bathroom. If anybody needs access to the Wi-Fi, we have the Wi-Fi password behind that TV over there. Just thinking like housekeeping stuff, I probably should have mentioned on the first part up here. But with our lightning talks, Daniel, they're getting Richard and Chris right now. Mauricio was going to need help plugging into an outlet for this transition period here. So I'm about to introduce Mauricio. I took charge of curating the speakers for the lightning talk. So the way PySanAntonio is structured, we have 3 main talks. We just saw one from Joel. We'll have Paul and Cody in the mix in a little bit here. But I have 6, there's 6 lightning talks. Richard, Chris, just to kind of plug in the outlet for Out Bionics. With the lightning talks, what I wanted to showcase with the lightning talks was the different use cases in the Python language. So what you're going to see here in a little bit is we're going to feature lightning talks that go over security, lightning talks that go over We have a mathematician that's going to be going over. We have lightning talks that are going over medical tech. We have lightning talks that are going over national security. And we're about to introduce Mauricio, who's an electrical engineer at a local company called Out Bionics. Out Bionics does robots. So just quick story. Folks in the service, folks losing limbs. He's found his specialty. The owner's a person named Ryan, who has really found the need and the market through robotic hands, and it's just mind-blowing. Hey, speaking of robotic hands, it's just mind-blowing just all the how the hand works, the things we take for granted. So I was super excited when I reached out to Out Bionics, and they said yes, that they would introduce to our audience how Python is used in the Out Bionics space. But with that said, let me take over the screen. I'll buy Mauricio some time. I want to share my screen. And we see new people coming in. Welcome. Again, thank you, everyone that's coming out. Help yourself to drinks. Hey! You got the shirt. I love it. Cool. So, yeah. So, once Mauricio's complete, we're going to introduce MJ. MJ is someone that I have worked with closely. We recently did a workshop together during Startup Week, going over agentic workflows, and he'll be going over how Python is used with the tool that helps amplify that, which is N8N. And let's see here. What else do we got here? But with that said, just let me know whenever you're ready, Mauricio. You're good. Time. I guess during that, so we will be approaching a break period. So I guess just to kind of retouch the break part. During break, we're going to bring out food. After break, I'm going to have two folks introduce themselves. There's a person named Christian in the corner over here. Christian, recent computer science graduate, was running a group, a data science group. That's kind of was his background there. Ended up taking over the AI group in San Antonio called AITX. And he just recently found work in San Francisco. So he's working for a company in that area, and that company is hiring. So he's going to be going over what they're looking for. Were you raising your hand, Ed? No. Oh, it's I got you. You're good. And if you don't know Ed is an OG in the city, from NVIDIA retiree, right? So all the headlines with NVIDIA, we have an OG and NVIDIAN.
I take full credit.
Yes, I love it. But we'll be introducing Christian after break. And I don't see Dee Dee here yet, but there is an after party. There's two of them. So for anyone that wants to stay on the third floor, we're going to be showing the Python documentary from a team called Code Repo. They do amazing documentary style stories. It's a 90-minute documentary, so folks can stay here. We got a ton of popcorn that we're going to pull out. And then for folks that want to get out of the space here, there's a group called the San Antonio Data Analytics and AI Group, aka they go by the Data Knots, and they'll be hosting the after party at Double Standard. We got the whole patio outside reserved for PySanAntonio. But with that said, I'll quit yapping. Mauricio, thank you so much for saying yes. And if you want to take over the screen, you can start sharing. And the floor is yours, and I'll give you the microphone. And again, the microphone is just for the live stream. So.
Okay, welcome to this lightning talk. My name is Mauricio Figueroa. I'm an electrical engineer at Alamo Python, and today I'll be sharing with y'all how we use Python at Alamo Python. So to provide some context, we make prosthetic and robotic hands. Today we have a robotic hand here to showcase how we're using Python. One thing I wanted to discuss is the QA process and how Python is involved with that. Also, how we use Python for prototyping, and we'll show that in a second here. So here's how the robotic hand is meant to operate. hand form factor, we expect hand performance. You know, it should move like a hand. And we'll do that in a moment here. So it should move as expected using hands. And so in this case, I just have a camera watching my hand, and it's mimicking what I'm doing. So how do we ensure that a build is successful? You know, like we take the time to get all the components, get all the PCBs done and whatnot, assemble them into a hand, but we need to make sure that it's operating as expected. And the way we do that is with a Python script. Specifically, we send all the different commands that this hand supports, and we're just observing, making sure that it does what's expected. And we can actually showcase that. So here we have the QA script that we use, and we like to just separate things depending on modularity. So looks like my VS Code is having a seizure. Hello? Oh yeah, had a seizure. Hang on. So we'll just reopen it. Here it is. Okay. So of course we have the script that runs the whole thing, but we like to separate it into a UI module. So this thing is all UI. Don't have to worry about it too much. And then the actual functionality is in this central script. And basically this just comes down into sequences, right? So one thing I'll show in a second here is the set/get joint angle test. And so we just have like a target angle. What's the tolerance? You know, it has to be within the tolerance, otherwise it fails, and so on and so forth. And to accomplish this, we have a command constructor, and this is something that we send out to customers, and we'll talk more about that in a second. But so if you run this, there's a bunch of stuff down here that shows up before the UI shows up, and this is basically preamble, so you can put like operator name, customer name, and so on and so forth. Before you get to the actual functionality, I guess, of the QA. So in this case, for example, if I hit set get joint angle test, we're sending a 45, so we're expecting all the fingers to move to 45 degrees. And then we're reading back from the encoders on each of these fingers. And then we're just comparing and going with it. And there's other tests on here. As the test gets completed, it gets appended, the results get appended to a PDF object. And then at the end, you can just hit generate test documentation, and it'll generate the PDF with the results. And we can see how that looks. So this one is very small because we only ran like a couple tests. Actually, we ran one test. But it does this for every single finger. All of them need to pass. And then there'll be other steps in the QA process. But in a nutshell, that's how we use Python for QA. So the next way that we use Python is for prototyping. And so basically, Python is really intuitive to look at. So that's why we use it for prototyping specifically. And I can show what we send out to our customers. And of course, this window is also messed up. So redo the window. Right. So this is what customers receive from us. One of our focuses is making sure that it is easy to integrate this into an arbitrary system quickly. And that's where we leverage Python. So in this case, we import the exact same command constructor we use for QA. And then as new functionalities get added, this command constructor also gets extended. And then looking at the code, you don't have to worry about it too much, but basically you just have the command constructor itself, you have argument parsing, you have serial communication, which is how we're sending commands to the actual robotic hand. And then we have some stuff relating to like, okay, what is the target angle that we should be moving to? And finally, you have this timer and it runs by some arbitrary time, right? But each time this timer expires, that's when it sends the command to the robotic hand. All that to say that as long as you create these messages, this surge message, it doesn't matter the source of the finger angles. You know, it could be a motion capture glove, it could be anything like that. As long as you pack it into this surge message and send it over, then the robot hand can operate as expected. So yeah, this is another example of how we use Python. The last example of how we use Python is for more advanced applications like operating a robotic arm. So the way we do that is we use Python to test new algorithms that we want to use to solve inverse kinematics. And so I don't want to show the code for that because it's super boring. It's just a bunch of math. But I did bring some footage of the different performance depending on the algorithm. So for example, this first one, this is a colleague of mine. He's piloting the robot arm with Surge on there. Surge is the robotic hand, by the way. And this last frame right here is what I want to point out. This was using like vanilla inverse kinematics, which is subject to singularities and a bunch of other stuff. And so you can see his hand is like flat, but then Surge is like this, right? Like the arm twisted a different way. And that's because we hit a singularity and the arm basically flailed. And luckily, it flailed downward into the table in this case. But yeah, I mean, that's how we prototyped quickly that mathematical algorithm in particular.
What's a singularity?
Singularity is when the algorithm goes to infinity. But there's other ways to describe a singularity. Like you can accidentally hit a pose that's not good, and it'll freak out. And so we solved that. Again, this is all Python-based. And we were just testing different algorithms, making modifications to different algorithms. And here we have an actual stable controller. So now we can actually move around and reach for things and whatnot. So I keep emphasizing that this is Python. And you can tell because there's delay, right? Like as I'm moving around, you can see the arm doesn't exactly keep up. I'm not placing all of the blame on Python, but it was a component on this latency that you can see. But again, we're using Python for prototyping, so it's just a lot more intuitive to make different algorithms quickly in Python versus like messing around in C++ or something like that. And so then here we have a version. Sorry, let me make this bigger. Here we have a version that has the latest algorithm, and it just moves a lot faster, and this is on C++. And so this is basically the end of this development cycle where like we test a bunch of stuff in Python, we determine a nice algorithm that we like, and then we port it to a more faster language in this case. But yeah, in a nutshell, that's how we use Python at Albionix. I hope that was interesting. Are there any questions? Yeah.
I have a couple of questions, actually.
Yeah.
What type of mathematics do you use for the modeling of the most? And do you use like partial differential equations or analytic functions, or how do you deal with that?
Yeah, so these are differential equations. I can show it actually. I mean, I might as well. So let's see. Let's go into Resolver. So take, for example, we didn't like inverse kinematics, so we decided to use quadratic programming instead. So here's how that looks. Now, if you ask me, like, do I understand the algorithm perfectly? No. But I like to treat these as black boxes, right? So it's like we have some inputs. The resolver does its thing. I just configure it properly. And then we have outputs. And in this case, the outputs are joint angles for each of the joints on the arm. And I mean, that's basically what we've been doing. Like, we check out research papers. There's tons of people like working on different resolvers. So that's where Python comes in. I mean, implement it on there and see what the performance is like and go from there.
So Python can do a lot of advanced mathematical equations as well as taking commands.
As well as taking what, sorry?
Commands.
Commands, yeah.
It can, you can ask it to solve like a partial differential equation.
Mhm.
If you have the parameters, and it will, and the input, and it'll find out what the solution to that equation is.
Yeah, so once you run this, it's doing a ton of math. Here, I think it's this one. Yeah, see, like, here's all the matrices and whatnot. This is for different models, so each one of these is a different arm. So really, you're only worrying about this component here. But yeah, if you chase the numbers around, it can get super hairy super quickly. But yeah, Python can run algorithms. Yeah. Mhm.
One final question for Mauricio? Oh, we got two. We'll do two.
I just asked, what's
Yeah.
the mechanics of the, like, is it servo driven? Is that a custom hardware inside that?
Yeah, it's custom hardware. So inside of here is a PCB that we designed in-house, and this whole armature is designed by our mechanical team. Yeah.
I had a question here.
My was raising is like how like actually in practice how do people use it?
How do people use?
Like if they have like like how they're actually using the
Oh yeah.
Yeah.
I wish I brought some footage to show that, but a lot of it is being used for like research at the moment. So they'll attach it to like humanoids and like do stuff with it. If you go to our YouTube channel, you can see examples of that. But yeah, I mean, applications are really endless. Everything is designed around people working with stuff. So it's like, it just depends on who's implementing what, like for what purpose. Yeah, so.
And that's a good segue. So like even like to how to find the Outbionics YouTube channel, I'll make sure that all the companies that are here participating, that their website and channels are available in this one resource page that about 90% done with that we're building right now during these talks here. But Mauricio, thank you so much.
Yep.
Appreciate you. Mauricio Outbionics. It's so funny. I ran into Ryan, who's the actual founder, just walking down Houston Street, and he always walks around with a limb. It's his business, right? That's just kind of marketing, right? That's just what I do. So just randomly, like giving a fist bump or a handshake. It's fun. The beauty of downtown. But with that said, we have one more lightning talk, and then we're gonna have Paul take us to our break, going over Django. During the curation of this event here, learned that this year it's 20 years of Django, so it's pretty cool to have someone that we can bring to the stage to talk about that. But before we get to Paul, I do want to introduce MJ. So MJ and I connected through a company called Learn to AI. It's a nonprofit on a mission to fill in the current gap. There's a huge education gap when it comes to just all ages and their understanding of like how to even use it. How do I prompt? And of course, the talk that the direction that we're gonna go here is how AI can be used in the go-to-market strategies, the agentic workflows. That's kind of the big thing. OpenAI just released their agent kit pretty recently. N8N, the tool that we're gonna spotlight right now, is labeled as a very developer-friendly platform, giving you the option to add some custom code to their nodes and their blocks and their layout, so you can add some JavaScript or Python. So that's what we're going to be spotlighting here. But MJ, thank you so much for making time for us here at PySanAntonio. You ready to go? Thank you, MJ.
All right, guys. Yeah, so my name is Mayank, actually, but no one can pronounce that, so you can call me MJ. I come from Learn to AI. As Jesse mentioned, we are a tech startup focusing on, giving AI educations to a lot of the small to mid-sized companies, a lot of startups, because the AI buzzword is everywhere, but people really don't know how to get it started, how to implement AI into their workflows, make the processes or whatever workflows they have currently in place. There's a lot of manual work in that, but they don't understand that we can also use AI to kind of automate the entire process. And so that's pretty much what we do. And so today I will be showing that how we can use Python to kind of create like a backbone, like a brain for AI automations and AI workflows. And so I do work with a lot of NA8, the NA8 tool, which show of hands, does anyone know, heard of NA8 before? Okay. Does anyone have heard of the ChatGPT, the OpenAI automation workflow, the tool that they came up with? Okay, so it's essentially what it does is whatever workflows, whatever processes you have, for example, going through internal company data to kind of find the insights, and then kind of briefing your team about it, if there's any latest updates about it. Someone needs to go through the documentations to kind of get the insights and then send it out to the team. So that's just one example of what a workflow might look like, but that entire process can be automated with simple tools such as NA8, Python, or any other tools you want to use. But NA8 is essentially like a tool that brings everything together and automates the entire workflow. And so today we'll look at, since this is a techie conference, I thought of a problem statement that a lot of developers face nowadays, especially the newly graduates, so someone who's passionate about building projects to kind of get their brain juice flowing about new tech, new products and stuff. And so where do we usually go when we want to kind of look at open source projects and stuff? There's only one essential place that everyone goes to, which is GitHub, right? But knowing GitHub, knowing a lot of these open source projects is, a lot of them are very depth and a lot of files are included. And so one who's not aware of what's happening in the project has to go through to kind of understand what's happening. But no one has time for that, let's be honest. And it's a lot of time consuming, it's a lot of effort to kind of even get started with the open source project. So the workflow that I have built just for the sake of this demo, which is, again, very low scaled, considering we only have 15 minutes, it is essentially replaces the entire workflow, and it automates the entire thing just by simply inputting a GitHub repo link, right, per se. So right here, you can see that this is the NA8 dashboard, and this is what automates the process. But of course, we need a brain behind AI to work and how and what it should be doing. And so for that, we have used Python in this case. Also, I'll show you how it integrates within AI, within NA8 workflow itself. But this is essentially what it does is it takes in all the user information that's been provided to the system, processes the entire thing. First thing first, when you get a link, you gotta have to extract all the information, trim the information, get the value that the AI could use to get the information, and then process all the AI insights and give it to the user. And so pretty much what this Python script does is that, right? Again, it's a very messy script. It was all last minute, but essentially it takes in the GitHub repo, processes everything, and there's no OpenAI key in here. Just one thing I want to keep in mind. There's no OpenAI included in this thing. So it's not ChatGPT, right? It's not ChatGPT that's wrapped in a container as a chatbot and it's processing it, right? Because as we all know, LLM models and ChatGPT are conversational. The user has to give it information. It has to provide, if you guys know anything about prompt engineering, it has to provide all the details as to what the role is, what the inputs are, what the expected outputs it is, right? And so this eliminates the entire thing. All the user has to do is provide the input, which is a GitHub link in this sense. And keep in mind that this tool, this use case is just one of many, and I will go into details of what other use cases are. But this is pretty much the Python script that does all the backbone, the back-end work for it. But we need to automate it, right? We need to make sure that someone who's sitting in an office doesn't have to go through all this information and do all the manual work for them. So then that's where this NA8 tool comes into play, where all of these are called nodes. Right, the first one, what it does, it takes in, actually, you know what, let me just show you the demo, then it'll make more sense. And sorry, Joel, I'll probably use your GitHub right now that he just demoed to kind of see how it works and what it gives you, right? And so let's see, this is the repo that I'm trying to work with, right? And what it is, I have no idea. And so if you go into this, this is just a basic framework, UI framework that I built to kind of show you the good stuff, right? So it's going through the repo, the details of it, what tools it's using, what it does. And it's not just doing that, because I know GitHub also gives you that, but it also gives you AI insights, where it's like, hey, the health score for this one is 18.44, which makes sense. It was just for demo purposes, right? But then this is where the main I guess, important stuff is, the AI insights, right? Where if someone is trying to build something and there's already open source project for it, but they can't just copy paste that. They want to integrate some of the features, right? They want to make it better. So this is where it could help. Like, hey, this is the project, this is where it's lacking, but these are the things you could do to kind of make it better for your use case or whatever, right? So yeah, again, just giving you some of the stats, also giving you the patterns that the person, whoever built this, or the team that has built this, the steps you can take to kind of make it better, right? And then of course some of the growth opportunities that are there with this repo itself. Now take this, put the GitHub use case in the back pocket, and think about this as an intelligent layer, right? An intelligent system layer that could be placed on top of any workflows, right? For example, a company has to go through tons and tons of resumes. Let's take a startup, for example, right? Your startup is growing. You want to go through hundreds and thousands of resumes. You want to also look at the person's LinkedIn profiles, right? You could include this layer on top of your workflow, and it will do all that for you. It will give you, within this took 10, 15 seconds. So within seconds, you have all the details that it could have taken someone maybe 2-3 hours, right? So it's automating the manual work. It's automating the entire workflow that takes someone hours and hours. And that's exactly what we can use in this case using NA8 and Python, right? So I'll just go over this very quickly, and then let me just show you. So you know how I just ran the workflow to show you what the thing it does? And so right here at 2:35, which is just now, it ran the workflow automatically. I didn't have to come here and manually trigger the workflow. It just did it on its own as soon as it detected the input came into the UI, right? So what it does is, of course, it takes all the information right here. It will show you all the raw data, but let's not worry about that, right? But right here, you can see that that's the URL that I provided to it, right? And then it takes all the information, it extracts all the information right here into queries, into headers, into a lot of bunch of other stuff, which we don't want to go into right now. It's very technical, right? And then this is where, this node is where it's connecting the Python, the brain, technically, to this automation workflow, where it's running that script, which I just showed you, this entire script, with the input that the user has provided, and it's going through every single detail for this repo. Of course, it's public, so it's able to do that. And taking all that information, now where it comes, the OpenAI LLM comes into play, because you want AI insights, not just information that's already given to you on GitHub, right? And so it runs all that information through this model, which is like a second brain for this workflow, and processes everything, gives you insights, gives you valuable contributions, growth opportunities, whatever the case may be. And then, of course, it gives you the final response, which, as we just saw in this case, right? So again, going back to NA8 workflows and automating systems, this is just one use case for it, right? This could be used in multiple ways. If you're writing if you're building something, you don't want to go through all the CI/CD pipeline issues and errors that you get at the end. This could be implemented into your own project structure and can run in the background while you're still working on the code, right? So it will run the workflow in the back end and giving you warnings like, hey, once you deploy this, these are the warnings you will get. These are the errors you will get. Fix this way, this way, this way, right? So it will give you suggestions. Now, big LLM models like ChatGPT, Gemini, and stuff, they do that, but you have to provide all the information, right? It's not automated. It's a conversational, right? And so NA8, tools like NA8, Python, we can use to build backbrains. We can train the models based on what the company requires. based on what an individual requires, right? So use case could be endless to this automation. And so, as I mentioned, it's not just ChatGPT or LLM model turned into like a chatbot, but it's an actual automated workflow automation that is done by AI agents in the back end, which could have taken some individual for like 2-3 hours or 4 hours or sometimes a day to do, right? And so, yeah, I mean, we could do this with anything. If we take another demo, right? So if we take this other, let's say I'm trying to build like a LMS system, and I found this open source repo, but I don't quite understand what it's doing. Like I need more details of it, and I don't have time to go through all the files and understand it. And so it will just run the analysis, will take 15-20 seconds, and while it's doing that, there you go, you have it, right? It gives you all the information. Anything that you could possibly want from the repo, it will give it to you. And if you look at the workflow right here, when you update it, it will show you that we just ran another workflow, automated right here, right? And it's giving you all this information live without manual work, which is just, again, one input, and that's all you need for this. And so, yeah, with that said, this is pretty much how you could, automate processes, automate workflows using Python, using any other tools. A lot of times what happens is you can get rid of the entire coding part of it. So any tool is great because you don't have to really code stuff. So all of this stuff, this is just for the sake of the demo, but everything could have been implemented right here, and it will do all those things automatically. You could schedule this, it will run automatically. You don't have to worry about it twice. And it will just do everything on its own with the training models they have provided to it. So yeah, awesome. That's automation for you guys.
Thank you, MJ.
Yes. If y'all have any questions, feel free to ask.
Any questions for MJ about N8N, automation? Oh, yep.
Yes, sir. Sorry? There's no much difference. There are a lot of similar tools. Zapier came first. It does a lot of, NA8 is the advanced one where it's user-friendly, so you don't have to know. It's easier to connect multiple endpoints, APIs. For example, you can use this with any other APIs that are out there, Teams, Zoom, whatever the case may be. So it's a lot more user-friendly in that sense. That's why it's a lot, I guess, preferred in that sense. And then there are a lot of other tools like Beam, Make, ChatGPT, OpenAI just came out with their own model, but it's not as advanced as NA8. They were one of the first players in automation that are very user-friendly. For even a non-technical person, while watching one video, could make a workflow, and it worked.
And I can extend to that. So normally most common, like a tool like a Zapier or a Make, they're kind of more in their if-else loops.
Yes.
If this happens, that's your trigger, the action. With N8N, it promotes itself as being like, build your agent, create this workflow, put this agent on this workflow where if something fails, go back, solve it, continue that journey. So N8N allows you to kind of go beyond that traditional if-else that you find with tools that exist like that here to really automate that specific use case that you're trying to solve for, whether it's for your personal startup, your business, or commercial client, and that's really where all like the focus. I work for a media company, so I'm the only developer on the team. I got a bunch of sales marketing folks, and a lot of them is like, we need to go to market strategies. We got to automate this email work. Well, we got to do that. So it's just it's understanding the core problem, how to get there from point A to B, and then with whatever tools that you use. Because the beauty is they offer so many connectors. One of my big frustrations with the marketing sales world is there's just so many tools. Like there's just so many tools, and they all kind of do the same thing. So it's like whatever tools you use, it connects to. But I'll put Yapin. I see a hand coming up. You got a question
Yes,
for
sir.
MJ?
So is this like it seems to me like it's a very like specific and focused concept of just like concepts like machine learning and neural networks applied to like workplace to solve those kinds of problems.
Pretty much, yeah. You put it right on point. So instead of like if we didn't have these kind of tools, we would have to sit there code for hours and hours to kind of automate processes And people have been doing that for years, but it's a lot of it's like months worth of work, where this is just like dragging, dropping, playing around with it, connecting different tools that your company or individual could be using, and just kind of automating the entire thing. We actually did a demo, as Jesse mentioned, where a lot of content creators or startups or companies, they need to do a lot of marketing. And so for that, someone needs to do research, keep up with the latest news, kind of put that into Word document, type things up. All of that is kind of manual work. But we have agents that does everything and also post on LinkedIn, X, blogs, wherever you want it, completely automated and trained based on your brand and your I guess brand tone per se. So that's another use case that you could use it. But yeah, it's pretty much that.
Thank you so much, Amjad. Paul, so we'll be having Paul give us, taking over the stage here in a second, going over asynchronous stuff in the Django world. Whoa, I'm just kidding. I guess while Paul's setting up here, one thing that I'm super excited about, so what's the future at DEVSA? We're super busy. When we first started, did a bunch of events. This year, we've pretty much scaled back and have really been more of a parent container for all the other groups, helping them with access to venues through the partnerships that we've been able to build, access to speakers and talent like an MJ and soon Paul. But as far as what's next, one of my big projects is connected to Learn to AI. We've met with the city, they reached out to us, but with all the restructuring, they used to have a platform called Smart Cities. They used to do SA Sandbox events, and they would pretty much bring tech talks to city parks. And with all the restructuring and funding, that program got cut, and they reached out to us to if we can help reactivate that. So with DEVSA having access to a bunch of community organizations that would be happy to be tagged in to help bring this to life. And then two, having a team like Learn to AI that can create a curriculum for that day where they can create an outlined curriculum. We tag in our community groups and we go to 5 to 10 city parks and just kind of bringing just tech to the people of San Antonio that can't make it to downtown and whatnot. So that's going to be one of our big campaigns that we'll be activating along with DEVSA TV and some other stuff, which we'll circle back to later. But I'll quit yapping because it's not about me. We got Paul in the house. Paul, floor is yours. Thank you so much.
Thank you. It's good to be here. Thanks for having me. All right. I'm going to talk a little bit about asynchronous programming in Django. So I wrote a book about this. There's a link here. You can get 40% off. We're going to give away some books too at some point. I think we're getting a raffle already. There's other prizes too. However, if you get the digital book, I have some physical books too. Django 6 is coming out. I'll do an update for that. You'll get that for free whenever that comes out. A little bit about me. I'm a former aerospace engineer. I work with Monty here. He really didn't like it, so don't ask him about it. I've been coding for about 20 years. I started using Django close to when they started at 0.96. And then currently I'm working as a principal engineer at Clarity Financial. We do financial aid. I think we do have an open position. So if you like Django or we have a React front end, talk to me. I'll show you where the job posting's at. All right, before we get started, this is an article that broke my heart this week, from the past week. It's a startup out in San Francisco talking about how they ditched their Python app and switched to Node because they couldn't get asynchronous programming right in Python. And it is hard to do, or harder. It's getting better. Django has had several different ways of doing things asynchronously. So that's why I came up with this book and this talk, because it's not as kind of intuitive as JavaScript asynchronous programming is. All right, so what is asynchronous programming? So basically, it's just a programming technique for starting tasks, and while you're waiting for those tasks to finish, you can do other things while that is, while there's time or the CPU is waiting. We can do other things. So a lot of times it's not necessarily doing things faster, but you can do more things at once. And typically in the Python world, this is what asynchronous program will look like, and we think of, and the same thing in JavaScript, right? We think of the async and await keywords. But it's really more than just that. And so I'm going to go through some of the techniques that you can use with Django to do asynchronous programming. All right, before we're going to come back to that. So why would you want to do asynchronous programming? This is actually an old chart, but it demonstrates the idea. So if you're working with the CPU or working with a disk or working with a network, this is the number of cycles that you're waiting for things to get done. So if you go to the bottom there at the network side, you call an API and say you're waiting, 100 milliseconds, which is really fast, I would say, for maybe an API over a network. That's still tons of CPU cycles that you could be doing other things. Now, this is a physical or a magnetic disk where that disks now are a lot faster. But still, even RAM or going to disk, there's lots of wasted or CPU cycles that you could use to do other things. And it's not necessarily that asynchronous program is always faster. So because if you look at this diagram, what happens when you're doing an asynchronous program is it's taking that task or that thing you want to do, it's putting it on a queue, and then you have a worker that does that when it's free. And so it's actually more complex, right? So it's harder to do. So it's not necessarily more performant, but it lets you use the CPU more. So if you have a program that's maybe running like 50% CPU, maybe you're able to split those tasks up and do it asynchronously, and you can use more of that CPU. All right, so what I want to go over is a bunch of the protocols and how would you do them in the Django project. So a lot of these protocols are asynchronous. So like, let's take a WebSocket. You're having bidirectional communications. So if you were to just, wait there and then do stuff and then send a response, you would start blocking a lot of things or a lot of requests coming over. So by default, you want to do WebSockets asynchronously. And a bunch of these other things, we'll talk about those as we go along here too. So, an regular normal HTTP request, that's a request response synchronously, and you can do it fast. Just do it synchronously. Don't get complicated. But a lot of these other protocols, you want to implement them asynchronously, because otherwise you're just going to have a really slow Django server, which I'm thinking is what these guys, they just were having a hard time implementing it. Like I said, it's not necessarily as intuitive, but there are ways to do it and to get it right. All right, so before we start any of these protocols, we have to know how to run our code asynchronously. So your normal Python projects like Flask, Django, name them all. Previously, they used a protocol called Whiskey. That is the synchronous protocol. So now you'll want to run your server with an ASCII server protocol. And these are some of the newer libraries that will run your code asynchronously. So if you do all the synchronous programming in Django and you're still running, like an old Unicorn server, you're wasting your time. You have to use one of these additionally. And a lot of these are pretty performant. I believe it's this one. I haven't touched this in a while. That basically runs the JavaScript loop, asynchronous loop. So they're very performant. They're very fast. All right, so let's talk about now actually trying to implement or run some of these protocols. WebSocket, if you haven't used it, is a bidirectional protocol. So like a normal HTTP request, when you go to the website, you request, you wait for a response, you get that response. With a WebSocket, it opens up a tunnel or a channel, and at any moment, something can send data to the server or back to the client. So if you were to block and just wait for things, you would block one of the ends, right? So with a WebSocket, we want to use asynchronous programming so that at any time, you can send the request back and forth. And so again, at the top here, remember to use your ASCII application instead of your WSGI application. And you'll see that in the Django project. If you use the starter template, you'll see a WSGI.py, and it will generate an ASCII.py. You want to make sure you're running this one instead. And then the other thing is out of the box, so this is also one of the things that's kind of confusing with Django, is that actually it can run WebSockets, but so normally with a WSGI project, you just run that WSGI file and your application, you're good. With a WebSocket, you actually have to go in, and right here is a setup of what you could do if you wanted to run a WebSocket. So you actually have to go in and modify that file. This right here will probably already be there. And so that will handle your normal HTTP requests. And so what we're going to add for our WebSockets is this WebSocket app. And I wrote a little library that simplifies that. Now, if you were to, and I have this blown up here. If you were to kind of write your own WebSocket, it'd be a little bit more difficult. But the example that I have here uses that library. So this is more like event-based programming. So if you use that library that I wrote, it basically, you have an on-open, an on-message, and an on-close. So when the WebSocket opens, you get that on-open method, and that executes. You can do something in that. When the WebSocket closes, it will run the on-close method. And then anytime you get a message, you get the on-message. So if the client sends you a message, you'll get that method execute. Now, you want to make sure you kind of, when you're doing asynchronous programming, you kind of got to go down the rabbit hole. Because if I start putting blocking code in here, I can end up blocking other things that are running. So you have to make sure you start doing things asynchronously. So like, if I want to send a message back, I want to do that asynchronously. Now, one of the downsides of Django right now is the ORM, the database layer, actually is not asynchronous. It will work, and they have asynchronous methods. So you can do it all, and it looks like it's asynchronous, but unless you have an asynchronous back end, and they're out there, you can try them now. There's a Postgres one. I actually haven't tried it yet because it's pretty new. But if you don't use that asynchronous backend for your database, all of your database calls are going to be blocking. So that's one of the things they were running into in that blog post. Again, this is evolving and is getting better. So I guess they just didn't know about the newer asynchronous backend. So you just have to be careful. It is a little harder than kind of just normal JavaScript asynchronous programming. All right, let's go to streaming. So streaming is, and probably most of you have not thought about doing streaming in Python because, right, it's got the reputation of being slow. But now that you can do things asynchronously, it's actually not so bad. I haven't tried this in production, but theoretically, it should work. So when you're streaming, right, you got this large file, and you want to send that down to your web browser. So if it's, let's say, a gigabyte, right, and it's going to take an hour to send through, you don't want to block, say you have 4 CPUs, right? And you have 4 workers that are able to process stuff. You could have one worker, right? If you did this synchronously, just block everything, right? So you want to do this in little chunks, asynchronously. Send a chunk, let something else happen. Send another chunk, right? If we go back to our chart, right, over the network, things are slow. So when you send a chunk, right, and it takes 100 milliseconds a second, we can be doing other things. We can be processing other requests. All right, so this is an asynchronous streaming example. These are just normal Django views. So Django views can just be a function. And if you put the async keyword in front of them, Django now knows to execute them asynchronously. Now, going back to the beginning, right, if you use that whiskey server, it's going to automatically convert it to just synchronous code. So you got to use that ASCII server if you want this to be asynchronous for real. It will run it, but it's going to be slow. Or blocking, I should say, not necessarily slow. So anyway, this is pretty simple. All we have to do is that piece right there. So this is the function down here. There's an HTTP streaming response, and then we just have to give it an asynchronous function. And we just need to return chunks of data in an async iterator. So it's just a loop, and we want to do it asynchronously, and we can return, so if you use, there's libraries out there for reading files asynchronously. You can read a file and then just send little chunks over and do that asynchronously. All right. Who knows what server send events are? Anyone actually ever use them? A few people. All right, so WebSockets came out, and they're very useful, right? You can send data either way. You can send it up to the client. You can send it back from the server to the client. Bidirectional, either way, right? So server send events are actually a lot easier to use, but they only go one way. So you open the connection, and then the server can send you an event. Now, there are some limitations in these. I forget what it used to be, that like you can only open 6 server send events for one particular domain. I think that's a lot higher now. I forget what the limitation is. So it's actually not too bad. But like I said, they're actually a lot simpler to use than a WebSocket. They can be kind of crazy because a WebSocket will die if it loses a network connection. A server send event in JavaScript will automatically restart, which is nice. So if you lose your connection, it'll automatically restart. But the problem is if you really want it not to restart, it will just keep on restarting. So you got to be careful, a little bit careful with them. Again, I wrote a little Django library to kind of make this easier. This, you could actually write it in normal synchronous code, but again, it's going to block the rest of your I/O if you do it synchronously. So this is what a server send event looks like, just in the raw data. So you give it a content type header, you say keep this connection alive, and then you just send events. So this, if you know how to send text, doesn't even have to be JSON. I just did JSON here. You could implement this very easily in just regular synchronous Django, but it would not be performant. If you had any sort of traffic, right, you'd use up all your workers, they would just get blocked and everyone would be waiting around. So we want to do this synchronously. Again, this is using that little library that I wrote. I guess you could call it Django ASCII. So anyway, it's just a class. It's a stream view, and then you inherit from that and just give it a stream method. And then the same thing, it's kind of like that streaming example. You just want to send things back asynchronously. So this is just like a simple weather, so it's weather API, I guess you could say, where you want to get the weather and then you want to subscribe to it and you want to get updates. So, it's looking, if you're familiar with Django code, that's a model. Weather point is a model that I made up. Again, right, just even though this looks like it's asynchronous because we got the await keyword, depending on your Django backend, if you just use the normal backend that it comes with, it converts it to synchronous code automatically. So, it's not going to be as performant unless you were to use the asynchronous backends that there are. So just be careful with that. But we get our weather point. We see if anything has changed, and then we send an event over. Then we send another event over. So basically, you have to be careful with WebSockets and server-sent events. Some deployment platforms will not keep that connection open. So if no data comes through that channel for a certain amount of time, it will close it. So right here, I just implemented a ping. So every 30 seconds, it's at least sending something to keep that channel open. And then after it sends that event, it just goes to sleep for 30 seconds, right? And so now during this time, since it's asynchronous, we could have another client make a connection and start getting that result, getting weather results for whatever weather they want. All right, so that's server sent events. All right, long polling. All right, this is an oldie but a goodie. How many people have used long polling? All right, we got some experienced people here. So before WebSockets and server-sent events came out, and they came out about the same time, this was how you would do long-running connections. So if you want data updated in real time, this is how you would do it. You still actually might need to do this. So depending on how, if you have a proxy or you're going through a firewall, a lot of firewalls will block WebSockets. And so you have to fall back to long polling. If you've ever used the pusher service, which I'll talk about here shortly, it initially connects with a WebSocket, but if it can't, it falls back to long polling. So what's long polling? So basically, long polling is you make an HTTP request, you keep it open until the data is available, and then when the data is available, you send it through, and then you immediately make another request to get the next piece of data. Right? And so if you're doing this synchronously, you get a request from the client, right? And now you're just waiting around for 5 minutes, right? Let's say to get your weather. This is another weather example. You would wait, right? And so if you had a synchronous blocking server, you would just use up one of your workers just waiting to do nothing, right? So if we do this asynchronously, we can let other people do things. So again, this is just a simple Django view. We put the asynchronous keyword. We get our request. We get our latitude and longitude. We start a loop. Again, we're accessing the database. With this one, just to kind of take the point home, I make it wait 30 seconds. And then down here, you can actually see we're actually sending a JSON response. Now, we don't have to actually implement on the server side doing the reconnection. That will be implemented in the JavaScript or on the client. So we just send through the data and we're done. The client in the browser now will start a new response, or a new request, I should say, and then wait for new data. But it's just a HTTP request that sits around for a long time. All right, moving on. I'm going through this fast, so you'll get your snacks fast. All right, so those are some asynchronous techniques or some asynchronous protocols and how you would do them in Django. If you said, I don't like this and I just want to do normal Python, well, this is the part of the presentation for you. Asynchronous programming is more complex. It's harder to debug. A lot of times when you have like errors and maybe it's something that got put onto that asynchronous loop, sometimes you lose the error messages if you don't log stuff correctly. So it is a lot more difficult. But there are servers, or services, I should say, that will help you do, you can basically outsource the asynchronous part to. So I put a couple up here. I've used Pusher. It's really good. Ably does basically the same thing. And then I'll go over this one. Let me just look through. Oh, yeah, okay. So this is a Pusher example, and I'll talk about Sockety here in a second. So with this one, this is the same weather example. We're getting, again, right, we're getting our weather point. We save it, right? So this would be an example of maybe a background task. So we have this background task that's getting the weather. Then we get our Pusher client, and we just trigger an event. So we have this latitude and longitude. We have a group that we're sending it to, and then we're actually sending the data. So what's happening? On the front end, you would actually have code that instead of connecting to your server and connecting to like your own WebSocket, would connect to a WebSocket with Pusher. And then you in the background just have like a celery task or some kind of background task that would just send data through. So when you do a trigger here, right, your JavaScript browser code is subscribing to that channel, and then it goes through the Pusher service, and then the Pusher service delivers that for you. So you're not having to worry about keeping an asynchronous connection. It basically goes through Pusher, and then Pusher delivers that for you. So if you don't want to have to deal with any asynchronous code, this is the way to go, and it's very performant. Now, Pusher, right, and Ably cost money. Sockety is a self-hosted version. Basically, that Pusher code, you can take it, self-host your own Sockety server, and it's all compatible. So you can basically run it yourself, host it yourself. And it scales pretty well. With one server, you can really push through a lot of connections. Now, the other advantage of doing it this way is that asynchronous WebSocket, some of these protocols are actually harder to scale. So let's say you want to have a subscription to a certain table in your database. And you know, let's take this weather example. So we have 50 million people that are subscribed to the San Antonio weather. That means that your server has to be able to keep, or servers most likely, if you got 50 million people, keep 50 million connections open. With a normal HTTP request, right? You get the request, you give it the answer, it's done, you go on to the next guy. With a WebSocket now, you're holding all of these connections open. So is your Django code, or is any code, right, your node code, how many connections can it keep open at once? That's a lot different scaling problem than scaling 50 million HTTP requests. So the cool thing with some of these services is they do what's called a fan-out architecture. So if you have a lot of people subscribe to the same topic, you know, they're getting the same data. Think of like a chat room, right? Discord. We're all in the Discord, hopefully. If not, join PySanAntonio. And then when someone sends a message, right, we all get the message that's in that chat room. So you want more of a fan-out model, right? So you push that one message. These services, everyone subscribed to that group, it will then send the message to. So if you're looking to do a model like that, of sending, you know, like data out to a channel that will fan out, these services are really good for stuff like that. If you're looking to do a model where like a WebSocket, you know, you have one user, like let's take email, right? Gmail kind of updates and just sends you your emails, right, as they come in. That's one user. It doesn't have to fan out. Everyone's getting their own data. That would probably be a good model for Django to handle with a WebSocket. Something like this, you might actually want a third-party service that's able to hold all those connections that you can send data through, and then it fans out and sends it to everyone that's subscribed. So, you know, depending on what you're doing, you might want to use this model. All right, so that's all I'm going to go over now. But there's more stuff in the book if you want to learn more. My daughter made all the pictures, so if you don't like the code, everyone's told me they love the pictures. So, also, if you want to see any of this code, there is a GitHub, and all of the chapters in the book, you can see I think there's 9 or 10 chapters. The code is here, so if you don't want to read about it and you just want the code, go look here. They're all in Docker containers. You can bring them up. And any questions?
Got questions? Go ahead.
I noticed you're mentioning a lot about HTTP. How does that compare to HTTP? One of the things use hypertext markup language versus XML now. A lot newer websites are using XML.
I mean, you can send XML over HTTP, so any of this could be adapted to that. Yeah, that's not a problem. Yeah. But be careful. XML, a lot of the Python libraries, right, they're all synchronous. So if you're doing a lot of XML parsing, you could block, even if you're writing asynchronous code, you could be doing a lot of blocking still with the XML parsing.
So how would you want to modify your Python backend so that you could do the asynchronous code with the XML part?
So I haven't touched any asynchronous XML parsers, but I've looked for that first. And then the other thing is, so there's no built-in, if you're using XML files, there's no built-in asynchronous files into the Python style library, but there are in PyPy. So make sure you're using asynchronous file libraries, and they've been around for a while. So make sure you're using that. I don't know. I haven't looked for any XML particular libraries asynchronous, but you'd want to look for that too.
Yeah, we got a question here.
So, I remember there was a part where you talked about asynchronous database access. I'm kind of curious, does Django support atomic operations or PyTexas or something like that?
Yeah, it does. Yeah. The question was, does Django support atomic operations? And yeah, it does. Yeah. And just so you know, I'll show you if I can look for it here real quick. It's SciCop G. 2 is the old one. That's synchronous. It's SciCop G3 that supports the asynchronous. So that's the new fancy stuff. And that's the one you want to look for if you want. Like I said, by default, this I think is still actually considered experimental with Django. So, but that's how you could use it.
Just be careful. PsychoPG has a sync and an async driver, so.
Yes. Yeah. You still want to make sure you pick the right one too. Yeah.
Well, with that said, I know we talked about books. So, Richard, you want to give us the download on these
Great
books?
talk from Paul. Let's hear it from Paul.
Paul, crazy. Thank you.
So Paul's greatly donated a couple of books, and he goes for a small fee. He'll sign them for you too. Okay, a large fee. How's it? So we have raffle tickets to give out. Oh, I should say this is a door prize. Sorry, Boy Scouts were never allowed to do our raffles. They always have to be door prizes or something. So I don't know if you want to just take one and stuff. We could cross them out. I don't.
So we're gonna do raffles for the books.
And then we're going to do 3 now, we're going to do 2 later, and then we're also going to use these tickets for the PyTexas.
Okay. So with that said, while Richard's passing out tickets again, thank you, Paul. 20 years of Django, and I'm just happy that we were able to bring that to San Antonio with your talk, Paul. Appreciate you so much.
I have a question.
Oh.
Who is using Django? Who knows anything about Django?
Who is using or knows anything about it?
Okay, both. Yeah, who knows? Who uses it? Okay, so who's interested in learning about Django? Because I'd love to do like a half day or an evening of Django. My son and I, we use Django a lot. So it's like the people that use Django use it almost exclusively, I guess. And then those that know about it. But it's like we'd love to do next year, do something on like an evening on Django.
That'd be amazing.
I mean, just think of the slides you could do with that. An evening on Django or something like that. The pictures, the GIFs.
I like where this is going. So this is going to be our break session. So we're going to take a quick 15. Was that tape that I heard? Was that food being brought out? We got confirmation. Richard, Chris, food's ready. Where do we have the food?
So it'll end up kind of coming through the kitchen here, loop it around the back.
So I guess whoever wants some HEB goodies, we'll just kind of do it. I think they're still passing them out. So definitely get a raffle if you want to get a book from Paul. Use this time to get some goodies from HEB. Thank you to HEB for sponsoring us. And if anybody goes to the PySanAntonio website, the resource page is officially live. So the slide deck from Paul, from Joel, and even Cody, who's coming up next, will be available on that site. So
When people get back, we'll do the drawing.
cool. All right, see you guys in about 15. craft beer at home. He brought a craft to the event today. So he's going to be setting up the CO2 so we can test out his homemade brown ale, I believe it is. But before we get to that, Richard's going to announce the winner of our books. And then we're going to have Christian go over essentially what he's doing now in the company that's hiring. Richard. Oh, it was your idea. I'm just kidding. We'll give Richard a second. But check those raffle tickets.
Okay. Roar them out. Okay. Vanna, the book.
What's that? All right, so we're gonna do our first raffle. We got our book right here. Async Patterns in Django. Ghost. Oh, pulling out the glasses.
Pull out the glasses.
Sound good?
Last three numbers. 255.
255.
Have to be a present and a wait to win. 255.
Going once, going twice. Next ticket.
Good grief. We only had 7 tickets we didn't give out, so like,
All good?
we'll try again. Last three numbers. 225.
225. Oh, we got a winner! I'll bring the book to you. Oh my God!
So we've got 2 more books after these 3. We're gonna stay until the end, and when we'll also
We're gonna give away one more, right?
we'll give out. No, we'll give both of these. We
Right
got
now?
2 more. Yeah,
All right, let's go.
2 more for later. Oh yeah, Paul was generous. Paul donated these books to us, so we
Thank you,
appreciate it.
Paul.
246.
What?
246.
We got a winner!
Oh, good. He just had questions about Django. Hey! And our final book right now. More later. Don't lose your ticket. 223.
223. 223.
Gotta be a 223.
Going once. Ah, Joe! Hey!
Oh!
All right, Joe. We appreciate you, Joe.
Thank you, buddy. Thank you. Okay, more later on.
All right, let me just confirm that.
Yeah,
That's a
confirm
223.
that,
That's a
confirm that.
223. All right, so Christian, it is your time. We wanted to. We're going to be introducing Cody here in a second. Cody came in from Dallas, Texas, so appreciate the commitment to come out here to San Antonio and help us activate the first Python conference here. But before we get to Cody, again, Christian, computer science graduate, was organizing a data science community, converted to the AITX group here in town, and San Francisco has taken him away from San Antonio, but the new company he's working for is looking to bring in some new talent. So I will quit yapping. Christian, stage is yours.
I'll just do this.
Yeah, just share the screen. Join the meeting, share the screen. And I just brought some more water, so there's more water. As we go through our ebbs and flows, if anybody wants to actually see the DEVSA co-working community space, we can take a little road trip to kind of check out the space that's available to work out of. We're on the 6th floor there. I'll talk more about the Christmas party. DEVSA will be hosting a Christmas party. We'll be doing it at 300 Main across the street. There's a rooftop up there. So save the date, Friday, December the 12th. We're going to be tagging in our bioscience community called Nucleate. They'll be providing the DJ entertainment, and we'll give more details, but it's just a nice way to kind of say thank you to everyone that's been following along on our journey and the stories that we're trying to tell. And it's just a nice way to kind of, again, say thanks and end the year on a high. So Friday, December the 12th, Christmas party. Let me know when you're ready.
Cool. Yeah.
I think I say yes. All right. Thank you, Christian.
Okay. Well, I don't really have much to show. So I recently joined Prime Intellect. We are 2 things: a GPU infrastructure company and also a research lab. So half of our company are researchers doing LLM research, a lot of post-training. And yeah, so we are hiring. I'm specifically hiring for applied researchers. These are some of the things on the left bottom hand side that we look for, as well as research residents, so like students at universities, people not in universities, just doing post-training research. We're happy to provide compute, as well as like we have a stipend residency. If you have some like novel idea, we can support, and then we can also work with you on a weekly basis. We're also hiring for GPU infrastructure, inference roles. And then some of the things on the right-hand side, if you have opinions on or just are interested in, come talk to me about those. We also have a bounty program. So these are like bounties that we're paying people to build out some environments, anywhere from like $200 to I think $5,000. Yeah, and so I alone have given out probably like $50,000 in compute in the past month. In total, over $100,000 across the company to other people who are doing research and we want to support. Looking to give out more. Also looking for people that want to build bounties. So if you have some free time over the weekend and want to make some money.
So when Christian talks commute and GPU, do we know what that means? Like, are we on the same? Like, do we know what he's talking about? Do we need any more clarification? Like, do we need to dig deeper? Just curious. But no, because it's huge. It's just having that available as a resource to be given away is pretty amazing.
Yeah, because I mean, a lot of people want to do research on LMs. It is a very expensive thing to do research on, especially at scale. And even like universities, I think UTSA has a high compute cluster, but it's like 5 years old, so it's like relatively slow, inaccessible to even the people, researchers at UTSA. So like those are the kind of people that we want to support. If you are doing research and need compute and like have a good reason for it, don't like come ask for $100,000 and like you don't know what to do with it. But if you know what to do with it, definitely would be happy to talk about.
Awesome. And I'll definitely, the new resource page that is live, I'll make sure to have a section just for Christian where you guys can reach out to him directly. But I definitely wanted to give him the time because you fly back to San Francisco tomorrow, right? So while he was in town, I've been a big fan of Christian since I met him a year ago and was happy to kind of plug him in this way. But thank you, Christian, for sharing what you're doing. We're going to miss you. All right. And with that said, Cody, Lightstar, SQL Alchemy. I'm going to give you the platform here. But again, thank you so much for traveling this way. We appreciate you, and we're excited to see what you're going to show us here.
Okay. Just a second here, guys.
Does anybody need me to grab it on water? Any waters? Any feelers? You want one, two? Four? Okay, I'll just grab it.
I'm joining the meeting here. Give me 1 second, guys.
And Daniel, once you get your home brew, just let us know. After Cody's done talking, of course.
We can start now if you want.
All right, who wanted some H2O? H2O. Anybody here? Anybody else? I'll turn around.
Okay, cool. All right. I guess I need this mic. Thank you, guys. So, hey, everybody. I am Cody Fincher, here to talk to you guys about a library that I wrote called Advanced Alchemy. So I'm sure that you guys probably are at least familiar with SQL Alchemy. This is a companion on top of that. And so let me jump into the right tab first. So let's talk about it. So a little bit about me. As was mentioned, I'm from Dallas, originally from Alabama, so if you guys detect a little bit of an accent, it is not a Texan accent, it's Alabama. I'm part of a team at Google called the Database Black Belts. My formal title is something really long like Staff Technical Solution Consultant, which really doesn't reflect exactly what I do. But the Black Belts, I guess that doesn't also reflect it, but really all that we do are, there's 10 of us, we are a global team, and we go around to all of our biggest customers and figure out what is not working and how to get them into the cloud. I've actually never worked as a developer. I've been traditionally a DBA, project manager. I have ran large teams. And about 6 years ago, I joined up with a startup, which happened to be part of the same team that I've actually been kind of going with for the last 10 years. And I picked up Python. And so I started working with Django. And I'm really fond of Django, but there are some limitations. And anyway, that led me to Fast API, which then is at the other end of the spectrum, kind of like what Flask is, where you have to build everything on top of it. And so at this startup, I ended up writing a bunch of stuff to add on top of Fast API. And a lot of that became Lightstar. So I don't know if anybody's heard of Lightstar, which is an API framework that's very much like Django or Fast API. It's, in my mind, it kind of sits somewhere between Django, where if Django has all the batteries and Flask and Fast API have almost no batteries, then Lightstar is somewhere in the middle of that. As I mentioned, I'm from Alabama. I'm a huge Auburn fan. My wife went to Auburn. I have 2 degrees from there. I generally like football. About 3 games into the season, though, this is really what's happening right now. So we're playing right now. Vandy's, I think we're actually up on Vandy, so we'll see how that actually comes out in a couple hours. Okay, so again, as I mentioned, about 3 or 4 years ago, I started writing the Lightstar framework. I'm not the original author, or I'm not the only original author. I'm one of them. But for Advanced Alchemy, what I'm going to talk to you about, I am the original author. And I guess I have to say this. This is not an official Google presentation, although the things that I'm going to show you, we actually are using at Google. And in fact, one of the tools, Advanced Alchemy, is part of this tool that I built called Database Migration Assessment. And so at Google, we've assessed about 100,000 databases in the last 1.5 years with it. That's all Lightstar. It's Advanced Alchemy to kind of manage the database backend. And so a little bit more about me. So I have been presenting at a lot of conferences over the past 6 months now. None of them have been Python. And in fact, this is my first Python conference. So I'm actually really honored to be here. And yes, that's awesome. And so the other thing on top of this is that I haven't written a book. So all these awesome guys that preceded me, I need to kind of get with the program and put something out there. So anyway, this has been a great honor. So thank you guys for inviting me. Like I said, I've been talking a lot about Oracle stuff lately. In fact, last week, the week before, and 3 weeks ago, I gave presentations here. If you want to see what those look like, you're welcome to. There actually is the QR code. There's an agentic demo that I did that uses Lightstar. It doesn't use Advanced Alchemy. It uses SQL Spec, which is another library that I'll tell you about here in a second. But it's all there for you to look at. And if you guys have questions about what I'm doing other than Python, feel free to ask me. So as this is not a Google talk, this is really going to be focused around Lightstar. And like I said, Lightstar is not just me. There's a great team that's global. One of the guys, Jacob Coffey, has presented at PyCon this year. He's actually worked for the PSF. There's another guy named Julian. He's in France, and he's in the bottom right down there. We all got to meet up at EuroPyCon this year. It was great to see these guys. And so there's another guy that I could not get a picture of, and I'm gonna call him out, but Yannick, he has to get his picture on this slide. He's the main guy. He's the guy that's running Lightstar at the moment. There's four libraries that we have that I'll actually want to call out. There's more if you go look at the lightstar.org, but of those, I'd say these 4 are driving the 65 million downloads that we've gotten on all of our stuff. So the first one is Lightstar. That is an API framework very similar to something like Fast API. The other one is Polyfactory. This was the first one, and so one of the things that I found out was that we had written Polyfactory, and when I got to Google, I found out that Google had already been using it, Mozilla had already been using it, and so Polyfactory is probably the one that's got the most active users, but it's a library that helps you like generate data and generate, you know, pieces that might be an artifact as part of your application. Advanced Alchemy, which is what we're going to talk about, is the SQL Alchemy companion library that we've got. A lot of the work that you guys end up doing in SQL Alchemy ends up having some kind of boilerplate added on top of it. And so what we're going to show is how I viewed that boilerplate when I was writing it at the startup, and then what became Advanced Alchemy. And then the other one, which I would love to talk about sometime soon, maybe next time they'll invite me back to talk about SQL Spec, which is the newest library that I'm working on. It is also a database-focused library that lets you execute raw SQL. It's designed to parse the SQL into an AST so that you can kind of manipulate the AST on the fly and add in things like, I don't know, like an is-deleted indicator. It's like an ORM, but not an ORM. And so there's some really cool stuff going on there, and it's got lots of active development right now. So I encourage you guys to all check it out. Let's see. So let's kind of just jump into things. So I don't know how many of you guys, I know we've got some Django guys in here, and I love Django. And in fact, most of my foundational Python knowledge came from Django. But I hit a lot of the limitations that we just mentioned on scaling. And so that kind of led me down the async path. And so what I've kind of put together here are some of the things that I know that developers are looking for when we start looking at libraries now. And so I guess I'll just do a show of hands. Who all here has used SQL Alchemy before? Perfect, okay. What about any of these other ones other than Django? Have any of you guys used Pony or Tortoise or ORMR? And then I had to put the one down the bottom, the no ORM, the DB API logo, so maybe you guys have used that. Anybody else use any of these other ones? Which ones? Okay, all right. Which, same? Okay, cool. So the point is that there's a lot of different frameworks to choose from. Something like Tortoise, for instance, it is very much like Django. So if you like the Django ORM, Tortoise basically brings that async native interface where it actually uses something like async PG as opposed to psycho PG and gives you a true async native ORM that feels just like Django. But what mostly happens is somebody realizes that SQL Alchemy is the only choice outside of Django, right? So if you're not using Django, what ORM do you use? And it's almost always going to come down to SQL Alchemy. And that's because, one, it's got 229 million downloads in the last month. So if you want to talk about something that has bulletproof level of support, SQL Alchemy is it. The developers on there are some of the most responsive and just they're very good stewards of the library, and so they're always on top of things. Whenever I ask a question, it's usually about an hour before I get a response back from the guy that actually maintains the library. So let's see. The other thing about SQL Alchemy is that there's two different modes. So you've got the ORM mode and you've got the core mode. So I hear, if you kind of think about the ORM being a divisive thing, there's people that fall on two sides of it. It's the I want to only do my ORM stuff, and the people that says I don't ever want to touch an ORM, right? And so this is kind of where core, I think, helps bridge that gap, because if you want to do things that aren't ORM-ish, you can do that. The other thing is that when you start designing models that aren't transactional, you start getting away from a third normal form type of design. That's where things like the ORM modeling doesn't really hold up all that well. And so you end up seeing lots of like hybrid uses of both core and ORM in the same application. But at the same time, and just like I mentioned that there's people that are on both sides of the ORM thing, that there's a hidden cost of flexibility here. The first thing, I come from organizations that have hundreds of terabytes of databases, maybe even petabytes. We're moving them. They have dedicated teams of DBAs, and so when things go into the database, they're very structured, they're very programmatic, and there's a lot of reviews that go into that. There's a huge disconnect that I see between the DBA and the dev when we start talking about SQL Alchemy, and that's because it obfuscates the SQL in a way that makes it look more like a Python object, and you don't really understand, what is translating into a SQL statement. I guess that kind of goes in the next thing. It feels verbose. So like you're defining joins and you're defining all these extra things, but you're not defining it in any syntax that looks like SQL. And so when a DBA goes to look at it, they're not really making sense of how this is structured. The other thing is that you have to know SQL. I know everybody tries to get away from learning the database, but you have to know SQL to be good at SQL Alchemy, because you don't know how to do the joins, you don't know how to do the table setup, and you don't know how to do the normalization. It takes a lot of that knowledge in order for you to know what you want to build and produce in SQL Alchemy. And the other thing is that databases are insanely complicated. They are really, really, like, it's one thing to run a MySQL database and a Postgres database in Docker and have 100,000 records, but as you start to scale to tens of millions and hundreds of millions, things become exponentially harder. And so the complexity of databases tends to get underestimated, and the further you get into your development cycle, the more those issues are uncovered. And then the last thing is that SQL Alchemy gives you basically every choice you could possibly want to make. And so how do you know if you're making the right choice? How do you know if you're doing the right design? Is there something better that you should be doing instead? So all these were things that I went through in my head as we were writing all this stuff. And it all boils down to, how do you make all these choices, right? And so just kind of to continue going on down this path, these are some of the issues that I encountered, right? Do I use UUID v7? Do I use UUID v4? And for those that don't know the difference, UUID v7, which is a new thing that's now supported in Postgres, the latest Postgres. You can also do it through standard Python libraries. It gives you a time-sortable UUID. So traditionally, if you store UUIDs as a primary key in your database, you can create hotspots, right? Or things that aren't sorted right. And so you end up with less performance than you might have if you were to just use an integer primary key. And so obviously, integer primary keys have their own limitations, right? And so you can end up going through these cycles of what do I want to do? And so the other thing is every time I started working with SQL Alchemy, I found myself saying, well, Django does this. Django does this. Where's my Django storages, right? Where's my Django files? Where is my Django fixtures? All these little things add up, and it really matters. And so basically what ended up happening was, we kept digging through this, and I guess I kind of talk a little bit more about what some of these issues are. Does everybody know what the N+1 problem is on an ORM? Okay, so for those that don't know, if you don't, let's just say that I select let's talk about authors and books. Let's say that I select all the authors, and I want to know about their books. I can get all that data in a single query. But if I don't set my joins the right way, then I could end up executing hundreds of queries to fetch each book for each author. And so the idea here is that you want to model and set your relationships in a way so that they don't do this kind of bad execution plan. Let me go right here. The other thing is that, at least now it's somewhat mitigated, but in the past, when you were talking about a sync-only SQL Alchemy, it is going to automatically go and execute those N+1 queries. And so it's harder for you to find out when you're doing them. You can mitigate it to some degree with async now, because it'll warn you. You might have seen a greenlit error or something like that when you were running SQL Alchemy. So this at least kind of helps you from, totally screwing up now. But it's not perfect, right? You could also do a raise load so that if you actually did do one of those executions, it would raise an error. But again, you have to know to do that. The other thing is that in Django, we have two different ways of getting data. You got prefetch and select related. But that's not the case in SQL Alchemy. You have at least 8 different kinds. And depending on what you want to do, you have to choose how to interact with those joins and the data inside of those. And we're almost done, I promise. But the other important thing is that the object state is tracked on the Python process. So as you select data from the database, it pulls into the Python process and it makes this session cache of all the things that are running. And so, I guess in a previous time frame, that was a very important thing to do. But I think now that as compute has kind of gotten to where it is now, this is like an extra overhead layer that doesn't necessarily have to run. And the other thing is that you don't know when your SQL is actually executing, right? Like if I run a flush or a commit or you don't know when that SQL is actually hitting the database and how many SQL statements that produces. Another thing, and so this is actually a good one, pagination. So when we talk about pagination, and by the way, I'm going through all the pain points that I found as I was working at this startup, all the things that I needed to make that were just kind of that I took for granted. And so if we talk about pagination, I have it right here. It's usually multiple queries to fetch the data. Does anybody know what's the minimum amount of queries that you can run to paginate the data and fetch the data? It's kind of a trick question. It's one. So it's one, and so we'll show you this. But there's times when you want to do that one query, and there's times when you want to do the two queries. At the same time, pagination is also difficult because one, you have to strip out all the limits and the offsets in order to get the total count, because you basically say, I want to get the first 10 records, but you need to know how many total records there are that match your filtering. And so let's look at what those look like. So here's a basic query. On the left, if you want to do an analytical window query, this is what that single query approach looks like. This is usually great, but if you have massive tables, this is probably not going to be the way that you want to do that. One of the reasons is the way the database handles the count star over the analytical window functions. A lot of that sorting, a lot of that ordering and counting happens after the data has been pushed up to the buffer cache of the database. And so there's a lot of extra work that gets done there. So if you have a lot of rows, it might not be the best way to do it. Usually you end up with this, most people go to this second approach on the right side here, where they'll run a query that has the filter on it, and then you've got a count query that gives you the total rows that came back from that query. The problem is, though, is that you've got to figure out a way to programmatically build this, right? You have to have something that can put these where statements together, knows to strip the limit and offset off, and leave the other where statements so that you can actually get a generic pagination component, right? And so what is the solution? This is kind of what led us into advanced alchemy. So has anybody heard of domain-driven development? No? A little bit? Okay. A lot of the concepts that you're going to see here kind of come from this philosophy, where you're going to focus on the domain itself, and a lot of the way that I kind of think about what I'm developing now is I break it down into logical chunks. And so if you're doing domain-driven development, you typically will see something called a repository pattern. That repository pattern is something that is a class that sits over your SQL Alchemy model that basically manages all the CRUD that goes into the database. So anything that you want to do to pull data or add data or modify data all goes through a repository class. You don't necessarily want to override those at all times, though, so you end up having a repository class that is part of a service. And that service is what has all of your business logic. So as you're building things out, you may want to have your database be mocked, which is where the repository is. You may have additional business logic that sits at the service. And so now you can much more easily unit test that stuff because you've got that separation of concerns that you might not have if you didn't build it this way. The other thing that I've kind of mentioned here is that we have lots of conversion that needs to happen. So if we're talking about an API, you're typically going to post data in JSON format. You might have like a pedantic model. You might have a message spec model if you're a Lightstar fan. But at the end of the day, those have to get translated into SQL Alchemy models that get executed against the database. And so we needed like utilities that would help do that conversion for us quickly and efficiently. And so a lot of what you see here is a lot of utilities that help do that conversion and help check to get data from one format and into a SQL Alchemy model. The other thing I'll mention here is that as a database guy at Google, I had to deal with tons of databases. And so one of the very first things we did is that it has to support multiple databases. So like if I wanted to write a JSON B column in SQL Alchemy, depending on which dialect that I used, I would have to modify that. And so what I wrote was like just kind of a shim on top of that says, okay, if I use this JSON B that we've created, then it automatically selects the right JSON B for whatever dialect you're at. Or UUIDs, for instance. Not every database has a native UUID type. But you almost never want to store that UUID as a string, because why? That string is going to be 32 or 36 characters, and you're going to end up taking a lot more space when you can store it as a raw, as just 16 bytes. And so what you'll see is that on databases that don't support UUID and do support raw, will store it as a binary or a raw before falling back to, last effort would be a varchar. And so let's talk a little bit about what that data modeling looks like. So as we started making all these like base classes and components to this, it shaped it to be this. And so there's tons of different data types. There's tons of different built-in base classes. And a couple of things that I want to call out here are, one, you see that we got this UUID audit base. This is basically saying that this model will automatically have a UUID column. It'll have a created at and updated at column that is automatically modified as the records are inserted or updated. The other thing is that we've got a slug key. And if you look at the slug key, and as you can tell, I'm a Django guy, but because that came straight from Django. Django uses this concept of a slug. So you might have a URL that you need to send out. And so the good example that I always hear is a blog post, right? So you might have an article title, and you want to slugify it to generate a valid URL from that string. And so the slug key is exactly that. So what we'll do is take in this case, we're looking at a tag, and this is a very easy way to demonstrate this example. So tags, for instance, are kind of tricky. Let's just say that I have a user, and I want to add tags to that user to say that, some type of whatever it might be. There's an intersection record that sits between the user and the tag table. And so if I add, let's just say I add cool to the Cody record, right, as the tag, then somebody else goes and adds that same tag in later, it should not do another insert into the tag table, right? We should reuse that tag that's already there. And so by default, SQL Alchemy does not do this. You have to code all that logic in. You got to code all the records to update, records to modify, records to insert. It's a little bit cumbersome. It's not hard, but it's just work you got to do, right? And so this is where this unique mix-in model comes into play, and it helps do that automation for you. And so, for instance, we define what is the unique filter for identifying a tag, and we define what is the hash for identifying a unique record of the tag itself. And you'll see here in a few how we use that. And so basically, we have a mix-in that lets us uniquely add tags, and it automatically behind the scenes will insert and update and delete without you having to do anything on top of that. Before I flip the page, I guess let me cover a couple of the other things here. I've mentioned the audit timestamps. I mentioned the UUIDs. I mentioned big integers. One of the things that I really like about the Lightstar community is that we're always open to adding in suggestions. Now, I've never used an Android, and I don't know that I have a reason to, but there have been a lot of people that do use them. And so nanoids are very similar to UUIDs. They're just shorter. And they are char-based, so that's one of the reasons why I haven't used them. But people do like them, right? And so little things like adding in a nanoid base or a mutable list or file objects, which is one of the critical things that I'll show you guys here soon. Also, we have things like password hashes and encryptions, and then time zone aware timestamps. So let's talk about a little bit about, after we've got the model in place, we add a repository on top of it. And this is what that looks like. So here we have an author repository, and we give it a model type to say that this is going to be the repository for the author model. And we automatically get all of these methods on the right side here. And so a couple things that I want to call out here. Has anybody heard of the Sentinel column in SQL Alchemy? This is a great way to illustrate this. So a lot of people say, oh, I can just go and call my add mini in SQL Alchemy, and it will do a bulk insert for me automatically. Well, the answer is no, it won't. Not always. It will try to do it. It'll fall back to a row-by-row insert, but you need some type of deterministic column automatically populated in order to get that bulk insert going. It's buried in the SQL Alchemy docs. I don't know if you guys have looked at the SQL Alchemy docs. They're awesome, they're incredible, but they're expansive, and it's really hard to read. Like, it is a lot to kind of take in. And so we did all this research for you, right? We did all this analysis. We took care of that so that when you use our audit base and you use a UUID column that's not deterministic, we automatically add in that Sentinel ID column, and we automatically populate the integer foreign key or integer ID so that you can get the sorting you need to do that fast bulk insert. The other thing is that there weren't really expressive APIs. So Django has some really cool stuff like get or create. Get or create was good, but it wasn't good enough for me. Because get or create, if I specify 20 columns, it's going to match on all 20 of those columns, and it's only going to create. But I need to do an upsert, right? And so what came out of that was get or upsert, where you specify the matched fields that you want to merge on, and it will automatically update the fields if you've given it different values, or it'll insert. And so this let me do a much more prescriptive merge than what I could do in Django originally. The other thing was list and count. So we talked a little bit about pagination. And so the list and count is an easy example where we return the record set and then the full count as a tuple. And then that's what you end up using for your pagination. So we'll see that here in a second. Let's see, the last thing is delete where that I kind of want to call out here. So delete where lets you basically specify any kind of predicate on the end and delete multiple rows. But as you can see, there's lots of different options for you, and they're all part of the repository that the service will be able to take advantage of on top of that. So let's look at what a service looks like. So there's a couple ways to define the service, and in this one, what you see is I've defined, well, excuse me, we're not at the service yet. We're at the repository still. So in this case, I've defined a US state model, and I have a US state repository. And this shows you how we can query with those methods. So the first thing I want to do is highlight the count method, right? So you really can put in your quargs into your argument, and those automatically map to a where clause. You can put in a SQL Alchemy instrumented attribute, so anything that you would normally do as a where clause in SQL Alchemy will automatically work in between any of these little parentheses. So whether it's list or count or whatever, they all take the exact same signatures, and so you can use the exact same filters wherever you want to. The other thing is that they also take what we call filters, or statement filters, I should say. The statement filters, and we have about 10 built in, but they let you do things like pagination or search contains or not in or in collection. And in is a good example of me highlighting again where we've kind of dug the legwork and found the most efficient way to do things. And so, for instance, if you're in Postgres, the any is much faster than the in. And so what's going to happen here is we'll automatically remap the in statement to any and do an array binding so that you get the performance benefits of using that as opposed to an in statement. You don't have to know any of that. It just works. Finally, so here we are at the first service example. And so again, just to kind of highlight, there's two ways to define a service. Here's that author repository up top. And you'll notice that we define the service here. And when the repository is defined separately, you'll see that I've added a second signature into the generic class up here to say, here's the repository type. There's another way that I typically end up doing that you'll see in the next slide. The idea here would be your business logic goes here. You get to have all your CRUD stuff stay up there, and you can mock each one of them separately how you need to. So here is the base example of the service. And so here I'm defining it the second way, which is where you can define the class inline. So you might see it, you'll probably see it more defined this way in my examples, but either way is fine. You specify the model type, you specify the repository type, and here we're saying match field. So we're saying this book, whenever I upsert or insert bulk, I want to make sure that you look at only the name, because it's going to have like created at, updated at, and a lot of other columns that aren't really part of that merge. And so we define which fields are unique here. And so now when I say to model, I can basically give it a pedantic model. I can give it a dictionary. I can give it a message spec, a Lightstar DTO. There's about 4 different things that you can give it, and it will automatically convert it into the SQL Alchemy model for you. Here we get a little bit more complex. And so You might want to override the to model to say, okay, I want to add in a default role to my user account when I create a user, or I want to make sure that when I create a user, I need to hash the password, or add some other kind of piece to it. You don't necessarily have to always override the to model. You're welcome to, but there's a lot of extra boilerplate that you might have to add in there and some signatures you might have to update. You can just call one of the built-in hooks. So like we have a to model on create, to model on update, to model on upsert. And each of these has what it takes to actually populate that model from that operation. And so in this case, we see how we would take a user and hash the password and add it to it. So if I actually posted something to the form with the user password in clear text, we'll automatically hash it and then store the hash password as opposed to the clear text password. The other thing you see here is adding a default role. And so this kind of goes back to my whole concept of how many inserts are running, right? And so in this case, there's multiple inserts that are going to end up happening out of this one statement. We're going to end up probably inserting at least three records on any new insert. So you're going to get the new user, you're going to get the user role, and then you may end up getting the role itself inserted if it needed to be created. Oh, there's one thing I actually didn't show here, and that's the to schema. You'll see this here when we get to the Fast API and Lightstar examples, but that to schema is a way for you to convert to and from a pedantic model on the way out to your response model that you might want to show. So if you want to paginate data, for instance, this will do this for you automatically, and we'll see that here in a second. In fact, let's kind of take this apart now. So we've got our book model and we've got our author model. So just kind of show you what this would, a very basic setup here. You've got an author service, and the idea is that we want to be able to select the author and return their books back as part of like a sub, like a child of that object here. A couple of things that I want to call out here. We actually are adding in some lazy select in, some lazy setups. What this means is that every time I query it, it will automatically do those joins in unless I override it here, which you'll see. This is both good and bad. You would probably only want to do this when you know that you're only going to query your data a certain way. So if you're always going to query your author and you must always have books, then you might want to do something like this. Otherwise, you probably want to do your joins at the time you execute. And so let's talk a little bit about what Lightstar looks like, and then the next slide is Fast API. So I showed you what the repository and the service looks like. That enables all the CRUD on that model. I can now create a Lightstar endpoint, and if you've never seen Lightstar, it looks very similar to probably any other web framework that you've ever looked at, but you've got a get route here. You define your dependencies so that you can do some dependency injection. We're going to inject a dependency called author service, which is that service that we just created. And then here is one of the nice things that we added in here, this load hook. So you don't have to know whether or not you should do a select in or a join load. You can just put in the column that you know needs to be joined, and we'll go and look at that relationship to see, oh, this was a list, or this was not a list relationship, it's a one-to-one. And so if it's a one-to-one, we know to do a join load. If it's a list relationship, we know to do a select in load. So you don't have to think about this. You just basically drop in the column that you want joined in, and it does the rest. The last piece is probably the other magic part of this, and that is the way that you want to have a filter. So if you have an open API or a Lightstar or a Fast API endpoint, and you want to have open API enabled filters on it, you might want to have something that looks like, and I'm going to just jump 2 slides here. So let's just say that you want to have something that looks like this, where you have a search string, you want to have it set to be where you can ignore cases, and then you want to have it pagination. This will let you do exactly that. So basically we're saying we want to limit offset pagination type, and I've explicitly called that out there so that we could add in things like cursor pagination or something like that, or keystone-based pagination later on. We specify the ID filter, so there's an ID in filter, and you'll see that it, for whatever reason, Swagger doesn't like to render the Open API 3.1 array strings, but if you were to use something like Scalar, it does work. So long story short here, we're saying, okay, I want the search enabled, I want search to search the name column, and I want ignore case to be on by default. And so that generates all of those necessary Open API endpoints and the schemas associated with it, so that you can use that in your downstream applications. The last thing I'll show you here is actually what the function itself is doing. So we're saying we're going to return this offset pagination class. All it is just a wrapper that says total rows, rows itself, and the current page and the pagination size. So there's like 4 elements on there. We return back this tuple of results and total, and then we pass it directly into toSchema. toSchema will convert it to the pagination class we need. So that's all that you have to do for the endpoint to get it totally paginated, totally filterable. And the beauty of it is that it looks, well, I thought I was showing you the Lightstar endpoint, and I was showing you the Fast API one. The beauty of it is that they look the same almost. And so here was the same endpoint in Fast API versus Lightstar, and it really is just, just moving a couple things around. But it's basically the exact same syntax, the exact same methods. And so now once you've put all your logic with the service, you don't have to worry about where you're burying that logic in the route endpoint. And this kind of goes along with probably a lot of the things that you learn when you start building comprehensive Django apps, where you put your logic at, right? And so the idea here is that it should not go into the route. It should go into something that's got the business logic self-contained, which is the service. Okay, so just to kind of cover a few of the filters. So I talked a little bit about what we had, and I showed the search filter, but we have a lot of them. So we've got not in, we've got search, exist, not exist. There's the multi-filter, which is still kind of evolving, but a lot of people have actually implemented it and taken things like, if you guys are familiar with ShadCN and React applications, there's like a tan table. People are using the multi-filter to generate the dynamic filters for the tan table in React, and so all this just works. Same thing for collections and all the other ones. Okay, so at this point, I was really trying to figure out what story I wanted to tell you, but there's so many features that I'd really just had to just kind of throw a bunch of slides together that kind of talked a little bit about the random things that we added in that are the nice to haves, because the little things add up, right? And this kind of goes back to what I was telling you about Django. Like, Django is really nice because it has thought about the little things, and maybe that's the fact that it's been maturing over 20 years. They've had time to really work on those things. But learning Django first really showed me what I needed to be thinking about when I was building this out. So the first thing, you've already heard me complain about it once, was bulk data loading. So fixtures, right? So in Django, you can export your fixtures, and it writes the data into a file system. You can then move that around or commit it to your repo, whatever you want to do with it, right? But you treat it like a way to seed your data or your database. And so one of the first things I did was built the exact same equivalent in there. So you have an async loading fixture. There's a sync loading fixture. And on the left side, you can see the service that I've declared for the role. On the right side is only the code required to actually bulk load that. So there's a role.json file on the file system that has all the roles that I'd like to load. I call the open fixture async, and then I call upsert mini, and it automatically inserts and updates the records based on what's in the table or the JSON file. Okay, so the other thing, Django storages. Anybody a Django storages fan? No? Maybe? Okay, so one of the things that kind of blew my mind when I was working with Django was the fact that I could write my static files, I could do collect static, and it basically packaged everything up for production. But when I configured Django storages and I added in like S3 storage, I could run collect static, and it would publish all my static assets to where it needed to go. And on top of that, I also had this file field that I could kind of keep in line with my transaction, right? So that as I'm updating things, that we could, delete the file as I delete the row, or save the file when I save the row. Basically tie it to the transaction status of the database record. So what we did was, after the commit happens, there's a secondary process that fires in the back end that actually does that data management. So like, as you issue a commit, we will save the file to the file system in S3. Or as you issue a delete, we'll delete the file from S3 automatically. So you end up getting a very Django storages-like experience, and it's built straight into the SQL Alchemy models that you're going to use. The other thing, I believe I mentioned earlier that a lot of your DBAs are going to say, hey, I don't get to see my raw SQL. I need my raw SQL. Well, you can do that, right? So there's SQL Alchemy Core, which is the Nato RM component of SQL Alchemy. You can also just run raw SQL statements. So there's a service that we created that doesn't take any generic argument. It doesn't take a model. All it does is has the pagination component and the two schema converter so that you can paginate and filter your raw schema or raw SQL like you want to. And so this is an example of how I use it to show, I think this shows like user count sign up over the past few weeks and group it by week. And so things that aren't very transactional or more analytical in function, so these kind of aggregate queries are perfect for this kind of thing. Again, there's so many features, right? So I still will go back through the code and I'm like, okay, I'd like to talk about this. There's so much that we put in there that is helpful in various situations. A couple of things I do want to call out is that, and I guess I just didn't mention this, but the Django, the storage piece right here, we have two backends. One of them is fastback, which you guys are probably all familiar with. It is basically what everybody uses for file transfer. It supports pretty much everything. This is nice because it gives you something ubiquitous that pretty much every library has at least some kind of support for. But if you need something more, there's obstore, and this is usually what I go to as my default. And in fact, you mentioned Uvicorn earlier. So I've actually moved all the way to a Rust-based runtime, and so Granian is the ASCII servers that I would recommend you guys look at if you're interested in that kind of thing. So if you're running ASCII, look again. We use obstore, which is Rust-based file storage. If you use the UUID v7 client-side implementation, it is also a Rust-based UUID implementation. And so, long story short, you have tons at your disposal for building out applications. And again, I just wanted to highlight that we looked at Fast API and we looked at Lightstar, but you can build this on your own. You can build a standalone application. You can build it with SANIC. There's a Flask plugin already available. There's a Starlet plugin. For the Flask plugin, there is a little bit of nuance there. So async Flask is a little deceiving because the event loop is executed for every request in an async Flask. So if you had, let's say, an async PG database pool, then it would get recreated every single Flask request. And so that's not a good use of async. And so there's another method that I've kind of been experimenting with, and it seems to work out pretty well, where I can run an event loop in the background behind the scenes, behind the Flask servers, and we can use what's called a portal to reach in and execute async at any point. And so from the portal, you can call in all of your async code and have it run on the fly from the sync context. And so that's one of the things you'll see that's a little bit different here that you might not see anywhere else. Let's see. I think I'm almost to the point where I want to take some questions. So let's kind of wrap it up. So again, all this culminated in what's called advanced alchemy. This is our tagline. We think it's, well, I know it's thoroughly tested, but I think it is a uniquely positioned library that you guys will all find value in, whether you're doing Fast API, Lightstar, Flask, Starlet, whatever it might be. There is a lot of a lot to learn in there, a lot to actually take away. Even if you don't end up using the library, I encourage you guys to go look at the code in there. There's things that I always learn when I go look at other people's stuff. So there might be some things that you're interested in there. And then, question. So if you want to go look at the Advanced Alchemy documentation, the QR code takes you straight there. There is, in the repository, there's an examples folder that has the books and authors model that I just showed. That's there. There is a demo of using file storage. Let's see, there's a standalone demo. And if you're really interested in like a full application, there is the full stack application on the Lightstar.org GitHub that shows from start to finish how to build the application. That actually very much resembles structurally what I'm running internally at Google at the moment. And then always reach out to us. I'm usually always on Discord, so if you guys want to join the Lightstar Discord, feel free to do so. Always reach out. Let me know if you got any questions. If you have features you want to add in, we're always looking for, one, people to suggest new features or people to add new features. So, and then, of course, if you find issues, we want to know that too. So if any of those three fit you, go to the GitHub, create issues, open pull requests, come and chat with us. We'd love to hear more from you. We want to hear how you're using the library. And I'd love to figure out how we can make it even better. So I think there's a lot to add, and looking forward to what the next year has for us.
Thank you, Cody. Thank you so much. That was fantastic. A lot of info to take here. But with that said, any questions for Cody? We got a hand. What you got first?
I wanted to find something out also. You said it's important to know SQL before you learn SQL alchemy.
No, I said it's important to master SQL to master SQL alchemy.
Okay.
Yeah.
What would you give as a good resource for learning first SQL and then SQL alchemy?
Let's see. That is a really good question. I probably should have prepared something for that. I don't know a good book. So I actually taught database 20 years ago at Auburn, and the books that I taught with 20 years ago are probably not very relevant anymore. And so I need to find, what I can do is I'll find some examples. I can probably, you're giving a link to this slide, right? So I can update it with the suggestions once I find them, and you can just pull it from there. How about that? And then SQL Alchemy, the docs, they're incredible. Like the SQL Alchemy official documentation is truly remarkable, but it is really hard to navigate. And you can find so much there if you just spend the time to read it. And so I've literally have read probably every page of the SQL Alchemy documentation, and it's incredible. There's examples that I didn't even realize that you could do with SQL Alchemy that they've got buried in there. And so that should be your number one spot. And so, and I guess let me kind of, I don't want to walk it back a little bit, but let me walk it back a little bit. And so don't not do SQL Alchemy because you don't know SQL, right? Explore SQL Alchemy, learn it, but just know that as you, to get to that next level, you're probably going to end up learning SQL to accompany it. And so that's not to say that you can't be successful without knowing SQL, right? It's just, it's definitely going to help when I say, okay, I need to do a left outer join here, or a full outer, or whatever it might be, right? So that you know how to change the join to do exactly that.
So, you know if there are any good online courses on SQL, from Oracle or someone?
I'll put, actually I do have a couple ideas for there, so I'll put them in here in the links that you guys can reference. And so, yeah, and most of my background does come from Oracle, but there are some free resources that you can use with Oracle to learn all this. And this will probably be the first time I'm going to say this, and maybe the only time. This is where Oracle really excels, right? Oracle has every feature you could possibly ever imagine that a database could want. They've had it for like 20 years. And so things that Postgres is just now doing, Oracle had 20 years ago. And so there's a lot that you can just learn by the way they're doing things, because it's where everybody else is going in the industry.
Any more questions for Cody? He brought up a good point, though. That's when it comes to having access to like a team maintainers, just a great foundational skill set when researching and learning is always documentation. So documentation goes a long way across any language, framework, and tool that you're using. But with that said, Cody, thank you so much. That was fantastic.
Thank
and
you.
yes, 100%. The resource page is live. So we'll be, as the event concludes and we meet up as a team, we'll definitely be adding more resources from our first Python conference. But thank you so much, Cody.
Thank you.
So with that said, it is, we're approaching the final block, so thank you so much for your patience. We're going to close out this block with lightning talk. So we're talking 10 to 15-minute talks. The three that are coming up next are going to be touching on cybersecurity. We're going to be talking, we're going to be touching base on just military healthcare as far as the Python connection there. And unless I get an update from the Cowboys, we're going to be going over mathematics in the Python space. But with that said, Karina, if you are ready, we have I'll let you come plug in here. Did you get the Google Meetup link? No? Okay. to share your screen. We'll get you caught up there. While Karina's getting caught up, though, we talked about Daniel and his home brew. Daniel, any updates on the homebrew craft? Is it ready for us to try? What do we need? Just cups? Do you want to talk about your creation? Whoa. Oh. Easy now, Dan. Don't put that energy out there. I know. Awesome. Awesome. Cool. And again, just to recap, once we do conclude, there's going to be 2 after parties. So there's a 90-minute Python documentary that came out from the team at Code Repo. Fantastic story about its grassroots start in Amsterdam to the global AI machine learning analytic machine that it became. And then for folks that want to get some outside time and fresh air, they already reserved a patio. They already kind of blocked it off. I see a hand in the air. What's going on? Sweet, yeah. Yeah, I was just talking to the double standard staff to make sure we were still good, and they are. So we are in a good spot there. But with that said, we will keep this transition. We're live? Yeah, you'll just share your screen, and we'll give, I guess, the folks that are grabbing a drink a minute or two, because now we got a line at the beer. All right, so we'll give everybody about, I guess, 2 minutes to grab Daniel's creation, and then we'll, sorry, Christian, we'll be right back for Karina, AI in the kill chain. And again, that mic is just for the live stream.
Okay, cool.
I'll come in and do...
Check one, check one.
It's just for YouTube.
Okay, so I can't hear anything.
The mic isn't for... Yeah, the mic is, we got Adam over there who's capturing our live stream. Well, thank you guys. Thank you for being part of this.
Yeah, this is just the first part of the presentation.
Yeah, go. And now they're at the dance studio. Sweet. And then the last one's going to be Sean right there with the glasses. Cool. All right, well, we're just going to go ahead and, you're good. You can go through.
How about, I don't want to miss this one.
Yeah, no, this is a good one. We'll give it 60 more seconds. All right, so we're going to start in 1 minute. 1 minute. 1 minute. Ladies and gentlemen, we are going to start our closing block of lightning talks. We got 3 lightning talks coming up next. Our first one's going to be from Karina on cybersecurity.
Hello, my name is Karina Alcocer. A little bit about me. I actually started in cybersecurity when I was 16. I got recruited by the Department of Defense to work for one of their cyber warfare squadrons, and I've been in cybersecurity doing different jobs from cryptography for USA, a few other things here and there. Anyway, this is my talk. So, with the advent of AI and its push in popularity, we're going to be seeing it a lot more. And one of the issues, I believe one of the earlier talks talked about it, how we don't really, most people aren't looking at security when they're looking at AI. And that's kind of an issue. As you can see, it's, there's a lot of tools right now that they're trying to integrate with AI, and depending on how that goes, we'll see. So, Python the cyber kill chain. So, there are a lot of Python tools out there right now that are used for cybersecurity. And in this slide, I'm going to actually show a little bit more about those. So, understanding the kill chain, that's basically how an attack happens from the reconnaissance. And this is the first stage. I'm only going to go over the first 4 stages because for ethical reasons. If you want to hear more about the other stages or a more in-depth of each of these stages, you can come to my talk at SAHA, or the San Antonio Hackers Association. So reconnaissance, it's the initial stage. That's when you're just gathering information, basically like a planning stage. These are some of the common tools that you can use for that if you're actually interested in that. Beautiful Soup is very, very powerful and is very well used. Scapy, specifically for creating custom payloads. I know a lot of offensive security people who use Scapy and swear by it. Request is technically not offensive by default. However, it is very easy to use the request library for offensive. Yeah, but if y'all are interested in that, that'll be a separate talk. The second stage, weaponization. So, this is basically whenever they're combining the exploitation with when they're actually pushing out the exploitation. So things such as creates deliverable malicious payload. Sorry, my apologies. So here's some of the libraries that use that. Scapy, like I said before, it's actually a really, really good library for offensive. So now we're going to look at the delivery stage. Dun, dun, dun. Anyway, delivery is usually a mixture of both technical and social engineering. So this is where you get from your phishing and things like that. As you saw in the previous photo, you see there's a little horse, for a Trojan horse, or oh, when you get that whole pop-up is oh, your computer is infected, click this. That's an example of a delivery method. And there's a lot of other delivery methods. I'm not going to go too in-depth into that. But, yeah. And social engineering is a part of it, but since this is a Python talk, we will talk more about that. One of the things that Python can be used for in the delivery stage is for automating emails, such as phishing emails. And there's actually specific libraries on the next slide that I will talk to you about that do that. And again, this talk is for educational purposes only. Please do not use any of these to attack anyone. And if you do, I will not be held liable in any way. To simulate user interactions, so you can actually, what a lot of sophisticated attackers will do is they'll actually use some of these tools to simulate interaction so that they can see how they can better where like possible stop gates are in their exploitation, so that they can find ways to like work around that and things. Transferring a malicious files to the target, well, that's basically what it's doing. Utilizing network protocols for payload delivery. I mean, that's what delivery is. So here's a few of them. Wi-Fi Fisher. These are all Python libraries, actually. So this one, yeah, it's supposed to be for Wi-Fi security testing, but you can also create a rogue access point with this and, you know, steal people's credentials and stuff. Kingfisher, realistic phishing campaigns, although it's no longer maintained, it still works, and you can still use it. eSpoofer, great for spoofing email authentication. For anyone who is familiar with some of the authentication for that, it actually bypasses the DKIM authentication for email servers and stuff like that. And then Fast Embed. That one, I like that one. It's lightweight. All it is embedding stuff into other things. So similar to how, I don't know if y'all saw that video of Network Chuck where he was talking about how like you can embed malicious code into emojis and things like that. So it's kind of like that. But this one's a lot more lightweight. Makes sense. So yeah. Exploitation. Yes, everyone's favorite. Exploitation. Steps explained. Exploiting the target. So here's some of the libraries in Python that specifically are used for this. So PyMetasploit 3 specifically is used with Metasploit. How many of y'all are familiar with Metasploit? Awesome. Well, this one lets you use Metasploit, so you can actually automate Metasploit tasks using Python. So you can, well, currently now, actual bad guys are using this, so yeah. And then Pawn Tools, that's for exploit development, so yeah, more crafting. Impacket, network protocol exploitation. That's basically what that does. And now we get to what we can do to help defend against these, which is threat hunting and machine learning. So a lot of these are using Python libraries, and the part that I didn't actually get to talk about too much, or I skipped over a little bit, is how with AI, a lot of the internal models that are made, you're actually able to not just automate these, but do things such as predictive. You're able to. Oh, sorry. Did someone say something? Sorry. Oh. So, what I was saying was for the skitlearn and the XP is that you can actually create defensive models for cybersecurity in Python using these libraries. And right now, adversaries are using they're using machine learning to help advance their malware and other things. So yeah, that's that right there. And now my second part of the second part of my thingy. Give me one sec. Let me stop sharing for a second, and then I'll do that again. So what I have done to try to combat this is actually create an entire framework built off of Python that actually not only automates the workflow between seams for your SOC teams, but also using models that I created myself and like trained myself. So it's actually not ChatGPT in a wrapper. It's like its own thing that I made myself. So let me get to that real quickly. Pull that up. Here it goes. Here we go. Now let me share this again. Sharing my screen again. Let me know if anyone can hear me. Windows. Okay. Sweet. All right. So one thing I forgot to mention is I'm also part of the AI Cowboys. I am their Chief Information Security Officer, their CISO. So that's cool. AI Augmented Cyber Operations Platform and Government Enterprise. That's basically what our new tool that we are putting out called Rodeo, which stands for Real-Time Observation, Detection, Exploitation, and Optimization. Basically, it's automating your entire workflow and then leveraging AI in the problem areas. So as like reformatting some of the data that comes out from one tool to another and doing things like that. There's a 3.5 million global cybersecurity workforce shortage. So, you know, that's kind of a lot. Aside from that, there's a lot of operational burnout. I don't know if any of y'all have heard of log fatigue, which is the exhaustion that individuals get from looking through logs for alerts and trying to find, you know, malicious activity. So yeah, that can result in burnout, which ends up exacerbating the workforce gap. So the cool thing about mine is it's actually kind of a purple team tool in the sense that it does both offensive and defensive. The offensive, however, is reserved for government. So yeah, defensive for the win. For the commercial side, ML driven. So it actually does triaging, and it has a 99.8% accuracy in precision. I've run that several times, and I basically trained it off of 27 years of CVEs, so since its inception up until 3 months ago. So it's basically trained off of all the like known vulnerabilities since up to 3 months ago. And the cool thing is that mine actually does predictive, so it actually looks for 0 days and stuff. And I forgot to mention the coolest part of it is, well, okay, aside from the civilian enterprise, which like I said, we're only selling the defensive to, we're only selling the offensive to the government, US government specifically. We're not traders. Anyway, so for the defensive, that's for civilian. For civilian side. And one of the cool things that also this integrates in is SBOM. Who's familiar with SBOM? Okay, SBOM. So that's dealing with the software bill of materials. How many of y'all, except you, can name a single maintainer of the libraries of which our technology uses? Nobody? So it could be some random guy in Nebraska, right? Well, what if one day he walks into the street and gets hit by a car? What happens to that library and things like that? You know, like most of our modern infrastructure is built off of these libraries, and nobody really knows who's maintaining them, or, you know, all these other things. And as we've seen with some of the breaches, such as the NPM breach, where, you know, malicious stuff gets pushed up, the management of your software supply chain is important. It could, it could completely destroy your infrastructure if you do not maintain it properly. And I think a lot of organizations will probably find that out very soon. So that's why we actually do a little bit of SBOM in ours. So not only does it actually automate your SIEM and stuff, it actually takes into account all the libraries and packages, where it's sourced from, and does checks against every single library. Over a period of time, it has to not bog down, because one of the cool things about Rodeo, super lightweight. It only needs 4 gigs of RAM to run.
2 minutes, 2 minutes.
Oh yes, sorry. So, blah blah, business blah blah. Anyway, that's me. And let me show you Rodeo. Let me show you. This is basically my baby.
Formerly known as Charlotte, right?
Yes, which stood for Cybernetic Heuristic Assistant for recon, logic, offensive tactics, triage, and exploitation. Try saying that 3 times fast. So this is one of mine right here. Right now you can see high risks. You can go in, actually get like investigative samples and things like that, generate reports, export data into other tools. It'll auto do that if you have your tools. Because the cool thing about this is it actually searches for existing tools on your network to integrate into its workflow. So you actually don't have to do any of that. The cool thing is it also looks at risk prioritization based off of these CVEs. Right now I have an entropy generator basically running through known vulnerabilities right now, generating and basing how that would be based off there. It also takes into consideration the prioritization of your devices. So, you know, a database with customer data is way more important than Joe from marketing's laptop. Yeah, so not only that, and it tells you, actually shows you how much time you're saving on your automation and workflow. Blah, blah. Again, if you're more interested, you can contact me later. It also shows how much in there, assuming that you only spend 100,000 on this, because people are spending hundreds of thousands to millions of dollars on their scene. And these devices don't talk to each other. And they're really clunky to try to get to talk to each other. Well, this does that. Also, it does real-time monitoring as well. So it can actually take into account different tools that are being utilized on the network as well. Again, I'm using a random entry, so that's kind of why the intent spikes. It also looks at policies, not just from the policies for Rodeo, but it can also take in GPO policies from your domain controller as well, and actually do that. We use YAML files to determine whether things such as, like, okay, let's say we see some data exfiltration happening. You want to isolate hosts for whenever it's critical, things like that, killing processes, stuff like that. It actually shows that, and it actually pulled this from the YAML file that I created earlier. Things like that, modifiers, data sensitivity. It can actually look to see if like things like credit cards are going clear text over network, things like that, stuff like that. And then follow-ups, general things. This whole thing, I forgot to mention, this is also completely modular, so all the aspects of it, it's interchangeable with other items. Seam optimization, I'm almost done. Security patches, right here, right there. 1 minute. Here we go. Okay, and then you can also input multiple sources of data for your Seam and things like that. So like Splunk, they're right there. And this is all written in Python. Okay. And it also has a temporary patch creator. So if it can't find an existing from a trusted source, it can actually temporarily create it, and it'll actually prompt you to see if you want to actually look through it, as well as the memory module that specifically looks through memory memory issues for memory leakages. So things like what happened with CloudStrike last year will not happen again. Sorry. Anyway, that is, yeah.
Thank you, Karina. And definitely, I'll circle back with you to see what, whether it's slide deck or what resource we can add to the new PySanAntonio resources for Rodeo. But any questions for Karina? Oh, we got a question.
Hello. Yes.
We'll start this way.
So it took me, since it was primarily me, with a little bit of Graham, you wrote the Zap plugin, but 98% of the code was all me, as well as the model training and everything else. So that took me like 3 months. So that depends on what my goal of the attack is. If it's financial gain, obviously it's going to be the database. If it's simply for chaos, any of the network appliances will do, specifically the DNS server. But yeah, and I do not recommend doing that, and do not do that.
Thank you so much, gang. Karina. Appreciate you.
Thank you.
So a new twist on rodeo. Let's rodeo San Antonio. I love it. Oh, wrangling in your adversaries. Love it. All right, we're going to continue our lightning talks. We got Janetto coming to the front here. One of my most favorite people in all of San Antonio, as I've been able to build some awesome relationships. Yeah, don't do that. And then Richard, if anyone, Daniel, Dungo, if you see Richard or Chris, let them know to move their signs to the double standard at the RSVP spot. I just don't know where they're at right now. So, and that started 5 minutes ago. But with that being said, no, Janetto, when I first, so my story real quick, I've only been in this space, community tech space for about 18 months. One of the first people I met at my first
And the TriQuest and Humanity group on the left side are the providers that are actually providing care, and they're using different parts of the manual. Some of them actually a year and a half, 2 years, 3 years old.
Not working? Is it working? Oh, cool, thanks. And so all of a sudden, that side of it became agentic, and being able to handle all the reasoning, when to go to which manual, the reimbursement systems, et cetera, when to use the providers, and when to look at CMS, Medicare, Medicaid for billing, I left all to the agents for reasoning. Now, I wanted to be able to provide the best information, and as you can see below the TRICARE manuals, you have multiple revisions. One of the issues is there's about 400 or 500 revisions for each manual over time, and 99% of that text is repeated. You see it over and over. What I did here is I recreated a revision index, and each vertical line is an actual manual. You see the current version and then going back in time. And a lot of this is repeated. As you can see in the top row, which is just chapter 1, the last change was all the way back here. And each individual version after that is just repeated. It's actually a copy of that. And right now, the only available versions of these are online in broken HTML that's an absolute mess. I tried chunking that, didn't work. I've tried turning it into PDFs, chunking it, that didn't work. So I finally went and just built it custom. And what I did is I took only the versions where there were actual changes. And I used Neo4j as a graph database and put the revision index in there. So I could actually go to manual, in this case, current version, and I would go to chapter 1, and then I would go and follow the inheritance all the way back to the last change. What that allowed me to do was go to any specific point in time, whether I wanted to choose here, over there, or a range of times, and say this particular manual was valid at this date, and for each chapter, tell you when the last change was, which it turns out became really important in military health care. 10 years later, they can come back and charge you $300,000 for a mistake you made, and there's no recourse because you don't know exactly what the policies were on that date. So the idea of being able to make this explainable and actually citable became very important. So for us to be able to go in and say, this is the manual, and be able to use the Neo4j database and walk back to the last change became really important. And when I was able to store the data from just the last change, I was also able to extract the before and afters. This is an example of one of the pages from the manual where I was actually able to turn it into a PDF, and it has all the strike-throughs built in, and so you have the before and after. That became an issue when I was actually chunking as well, because it chunked both the before and after. So I had to go through and do a very interesting custom data extraction to be able to pull the right data. What happens is if you don't actually extract only the versions that are on that date, you'll do a query such as this: what's the copay for office visits? And it'll give you every single version because the text is almost the same. So it'll give you an answer. The copay is between $15 and $20. The answer is correct, but it's not accurate. So being able to actually leverage the Neo4j database to actually look at that revision index allows you to go in there and pick out only one of these. What it actually does is when you actually walk back, it takes that specific revision and it builds a list. And when you do a Weaviate search, the reason I chose Weaviate as a database was it actually has a schema built in, and it allows you to filter on different information. So I could actually filter on a specific date. So by going through the Neo4j, I built a list of specific revisions that were important, and then I went to the Weaviate database, did a vector search, but only on the revisions that were in that specific time frame. And it cut the time down by probably 99%, being able to eliminate all of that repetitive information. So the vector database approach fails in a lot of ways when you're looking at complex policy. Not only do you have the problems with the temporal data, but you also have a lot of repetition throughout all of the manuals. And when you have all these context, I guess you call it context pollution, when you actually build these prompts and there's 15 sentences saying the exact same thing, it tends to bias the output. So trying to really narrow it down and focus on what's actually true and most related to a specific request became really important. One of the other things I want to add back here, when you look at the hierarchy, this was also one of the other difficulties that I came across. As you go deeper, you end up with what's called conditional hierarchy. this particular chunk may only be true depending on what that says. A good example would be for autism treatment. It says autism treatment is valid for children under 18, but then the next sentence or paragraph explains in detail what that autism treatment is. So if you do a query and you had just done general chunking, it'll return that paragraph and say, here's the treatment for autism. It'll leave out the part from the sentence before that said it's only valid for people under 18. And you run into this type of conditional hierarchy in a lot of different manuals. I've been asked to actually try to apply this to customs as well as other financial documents where you're actually able to get the hierarchy, which I also built into the Neo4j. Now, the reason I chose Neo4j is it's really well developed. There's multiple databases like OrangoDB that have both the vector search and the graph database built in, but they aren't as well developed. And when I tried to use them, I'd run into problems, and there's no one to pick up the phone and call, and you're digging through manuals and working online trying to find the answers. I was actually able to pick up the phone to Neo4j and speak to one of their senior architects to help me figure out how to do this best and find out a new way to do it, because most groups do the Weaviate search, and then once they find a particular semantic match, they'll go to the Neo4j database, and then they'll look at all the siblings, they'll look at the different paragraphs around it, they'll look at the parent, and then put all of that in the prompt for the LLM to be able to make a decision. So I actually went to the graph to pick out the correct time frames, then Weaviate to be able to actually match the right context, and then back to the Neo4j database to look at the parent to make sure I got that conditional information. So when I build the prompt for the LLM, I have the accurate information to be able to move forward. The last thing that I did is I also added content hashing. Every time I embedded one of those little sections, and I'll go back to this again, you'll see that this is the only section that changed in the whole chapter. Everything else is again repeated. So not only do you have the repetitions on the chapter and section level for the macro, but once you actually return the actual document, you realize that each of these is actually repeated as well. This is the only thing that's different. So for each section that I extracted, I have a content hash, and before I embed it, I check to see if there's a matching content hash, and if there is, I don't need to embed that further. I just make a reference that you're seeing it in all of these different versions. So the whole goal here is just a novel way to reduce as much of the repetition as I can so I get the most accurate data and hopefully the best answers. One of the issues I was told specifically with TRICARE, it has to be 100% accurate. And that's really, really difficult to do with AI and LLMs. So one of my things that I first came across in this journey is it's really easy to build an AI app. It's extraordinarily difficult to build an accurate, reproducible, cost-effective, scalable generative AI app. Yeah. Yeah, that was my, and I just lost my chief technology officer to a company called Zero Hash that gave him an offer he couldn't refuse. So now I've had to go back and learn all the Docker, Kubernetes, Prometheus, Grafana. So it's been, it's entertaining. So, this is the content hashing. I already covered that. And when you need this pattern, and for a lot of patterns, it is overkill. If you're just chunking just newspaper articles, or you're chunking a cookbook, it's one set of data, and you don't need to worry about it. But when you start to have all these different conditionals, and you have all the different time frames that start to become important, these are things that you really need to look at, and there's novel ways to be able to approach it. A lot of what I'm doing is computationally expensive, and I was able to do that for the TRICARE manuals because they only update once every month, and it's not a whole lot of updates. As you can see, it might just be a single sentence. So when I first onboard a customer, I'm able to actually load on all the data, put everything into S3 that's static, all of the images and whatnot, put the full JSONs in Mongo, and then build out the Neo4j database, and then go ahead and chunk into Weaviate, and you essentially do it once. And then you can check weekly after that. So I was able to use some novel approaches that may not work when you start to have huge amounts of data. A good example, when I am actually able to filter down into a list of the revisions, that works because there's only 150 chapters and sections in each manual. So I can get a list of 150 chapters and sections to filter on. According to Weaviate, if you go over 1,000, it becomes inefficient and ends up being problematic. So I was able to do some things that I probably wouldn't do in different circumstances that were able to make this a lot more accurate. And being able to use the models like Phi 3 Mini ended up making my life a lot easier. When you start to use, I guess what's called multi-inference GPUs, so you could take one GPU and actually put 8 different instances of Phi 3 Mini on there, so I could have all 8 of the agents actually working at once. Ends up being computationally a bit more useful and fast. I've also tried to switch out the model weights depending on which manual I'm looking at, operation versus reimbursement versus systems, to be able to get more accurate data. But I was actually getting such good results with just the basic model that wasn't even trained on healthcare information, from just providing the most accurate prompt, that I haven't had to move beyond that. In the future, it's something I'd really like to be able to revisit, but you know, time frames and whatnot, and building it on my own now has cost me a little bit. So essentially, the key takeaways when vector search isn't enough, when you're actually looking at the time again and you're looking at the actual different hierarchies, and then the last step is actually looking at semantics. When you're actually able to use tools from Neo4j, like their data science library, it actually picks out words and starts to build different connections in between. In this case, for healthcare, say CPT code, for instance, 99453, that'll be in the data. That'll be in the database and be able to link to other sections of the different manuals to be able to pull in all the relevant data. So there's a big balance between having too large a graph database with too many connections, but having enough that you're getting all of the relevant information. And I do want to apologize. I was supposed to have an actual prototype here, but when my CTO left, I didn't get a chance to get it up and running. So I do apologize. It would have been a little bit more fun. So it ended up being so it ended up being just a little bit more educational. That context for me turned out to be key, and it's a little boring. You don't hear it from a lot of the AI companies that are out there, but probably 99% of this stuff is actually the context engineering, and you can solve a lot of the problems you have with LLMs with taking the time to do the boring stuff first and actually making sure you spend a little bit of extra time doing the data engineering, and then the rest starts to fall into place pretty quickly.
Love it.
Yep.
Love it. Well, thank you so much.
You're welcome.
Yeah, thank you.
And one thing, also, I'm going to end up providing all the resources.
Yes.
But this book, The Essentials of GraphRag, actually gets very deep into it, and it's inexpensive, and it's only about 100 pages long. So it's actually one of the more palatable books on generative AI and agents and whatnot that won't kill you.
Well, with that said, do we have any questions? Oh, we got some hands.
Questions?
Let's hear it. Let's start this way.
So when you were testing all the different models to get your best bang for your buck, so to speak, how did you do that? What type of benchmarking?
Humans, real people. I started off doing it in just chapters and sections, a specific chapter, and the company that I'm working with, Tactical Rehab, that asked me to see if I could build this, they have experts on the billing. So they would ask questions, and then I would let them look and review the answers. So I actually did it first round by hand. I'm also looking into OPIC and probably Ragus to be able to look at some of the evaluation metrics. But to start off, I actually wanted to bring humans into the loop, because it's a topic that I didn't know that much about, and the military healthcare is so complex. I felt that I needed someone to be able to say, yeah, this answer is completely off base, or actually this is an excellent answer, rebuilding the model, rebuilding the tables, which I left that part out, but also there's multimodal data. And it got to the point where it would actually rebuild the tables for them and be able to answer questions about forms and whatnot. So I was able to get very detailed questions. I also, as I was extracting all of the data from the HTML, I was building question-answer pairs. So that way I could have AI-generated question-answer pairs that were pre-built, that were from small amounts of data, so they were pretty accurate, rather than taking a huge chunk of data and having them pull out actual question-answer pairs from large amounts of data. And I learned that trick from the guy at Neo4j. He said, if while you're doing this and you're building your initial chunks of 500 tokens, have it come up with 2 question-answer pairs. So I was able to do that as well, to test the question and see how relevant the answers were.
Great question.
Yeah, thank you.
Great answer, too. Wow.
Good
Any
question.
other questions? Oh, right in the front.
So essentially, your struggle with the TRICARE is getting your generative AI models to understand the nuances within the memo
Yes. In short, part of it is you have the TRICARE manuals. They're voted on right now. They're on T5. The problem is the actual people providing the care, and they're like Blue Cross Blue Shield. They, right now, are not using the T5. They're using the older version. They have not implemented it, even though the Defense Health Agency voted it in. Don't ask me, it makes no sense. But then all of that is based on Medicare, Medicaid on a state-by-state basis, how they actually bill. And then depending on which insurance company, it's 65%, 80%, and it's just whacked out. And like any good government agency, the HTML that's online is only searchable right now by keyword, and you can only go through page by page, and it's completely broken HTML. There's no clear classes, no clear IDs, which is why I've had to go in there to build the ETL pipeline to extract everything manually. And once you take the time, then things fall into place. But it's a mess, and I found out that that's extraordinarily common in any government website. The humorous part is when you get into it and you start to look at it, somebody at some point must have had an idea that something like this was going to be built. The amount of internal and external references in there to reference each subsection and each image and sections of images and forms is incredibly detailed. So all the information is actually there. It just never got used, which I thought was actually pretty interesting the more I dug into it. But thank you for the question.
Got time for one more question. Let's go. Coden.
All right, so you mentioned the accuracy of the vector search and creating duplicates and those kind of things. I'm curious if you experimented with different embedding models and what difference that made if you did.
Right now, because I have it working on my workstation at home, I'm actually on a smaller embedding model that actually came with Weaviate, and I believe it's 357 long. They had an option for 1200 and 1500, but because I've kept my tokens down to 250 to 500, the smaller embedding actually worked out pretty well. I haven't had a noticeable difference.
Do you think it actually would help in the case? It doesn't seem like it might help. I mean, it seems like you might still get those duplicates that you showed on that screen, but it may help in other cases.
And it might. The problem with the healthcare, even once you remove all the duplicates, so much of the wording is so close to the same. I mean, your cosine differences are like 0.00001 apart. So if I actually jumped up to something that had a embedding length of 1500, are there odds that it might pick up more nuance? Yeah, more than likely. And I hadn't actually thought about it until you brought it up and we're talking about it. And that actually might make a lot of sense. So either I could increase the whole, the chunk size, or actually increase that embedding output that might pick up more nuances and really start to separate that overlap more. Yeah, no, that's a good idea. I hadn't actually thought of that. Thank you.
Thank you for
I will reference you, and I appreciate it.
Thank you so much. Appreciate you. Appreciate you. The man, Janetto. But with that said, we've made it to our final lightning talk. So no pressure, Sean. We're all feeling the vibes. We love it. It's getting dark in here. But it's so funny. I was talking to the bioscience team the other day, and they were talking about their mathematician who's working with in the science space. And I was like, yeah, it's amazing. I know of a mathematician that's done stuff with NASA. It's like, whoa! So we're bringing in Sean, mathematician, NASA contract work. But the title of the topic here is math and Python from the lens of a mathematician. But anyway, I love Sean. He's been just a great friend to hang out with and learn from in our co-working space on the 6th floor at DEVSA. And I was excited that he said yes to partake in the first ever Python conference in San Antonio. His screen is up. He's ready to go. Sean, floor is yours.
Oh boy, man. Well, of course, thank you so much to Jesse for that awesome intro and for being such a great guy, and thank you for Geekdom for hosting us in this space. So just a quick bit about me. Recently graduated from UTSA with a master's degree in applied math. My degree plan is no longer there, ripperoni. But I've put on many hats: mathematician, statistician, physicist, mathematical physicist really, musician for a while, kind of. And chess player, is maybe you can kind of infer from the picture that I have here. So I found this post on r/data-is-beautiful a few days ago. Someone took games from the Open Lichess database and just gave kind of a cluster of like, what kinds of openings players play at like certain rating levels. I was trying to find more about how the picture was generated, but you see like there are these clumps, many people that play similar openings kind of at the same rating level, or just like some sort of classification. So like a lot of people, they'll play like the modern E4 G6 and then some other stuff. Some people will play some variants of the Caro-Kann, E4 C6, D4 D5, and then go from there. But the question is, how do we actually get here, and like how do we actually produce these kinds of things? Everyone's talking about data science and machine learning and AI, but what is really at its heart? Well, to me, at its heart is just the mathematics behind it. And this is not going to be very, very in-depth. I mean, Manny and Alessandro know I do like to talk. I mean, you throw an integral at me, well, first I'll cry because I've done enough of that. But I love talking mathematics, and then especially with my computer science students that I've had at UTSA and engineering students, they're like, hey, I want to get into data science. What should I do? Take linear algebra. Wait, what? Yes, take linear algebra. You need it. Absolutely. Vector calculus, everything. So the thing is just like, why math? Why applied math? So it's our modern world, really. Okay, we're familiar with a lot of machine learning stuff. All that's based on optimization. Okay, so your gradient descent, say, stochastic gradient descent, AdaGrad, all those algorithms you see in the PyTorch and TensorFlow documentation and in scikit-learn. Linear algebra and differential equations for engineering, OMG, they are those two like intertwined. You have a hard differential equation you're trying to solve on like this infinite dimensional space. Well, of course, infinite dimensional spaces are hard to look at. So what do? We look at finite dimensional spaces because we can actually look at them and picture them and kind of give some reasoning to it. Okay? In fact, linear algebra, discrete problems, helps us solve continuous problems, or at least give approximations to continuous problems. So that's neat. And the amount of statistics, my gosh, it is huge. A lot of modern statistics has really evolved because of the advent of machine learning. Now, of course, computers can do the heavy lifting, okay? Yeah, you take like, freshman stat, freshman calc, we talk about like, oh yeah, we just find an antiderivative and evaluate on the boundary, we win. Linear algebra, okay, AX equals B, we know how to solve linear equations. Statistics, we look at a group of 20 samples, we get an average, get a variance, get some information about that. But what about the actual large data that we see? I work with like some of my databases at work, well, provided I actually was working, that's a different story. Some of my databases are like hundreds and thousands of records, millions of records. How do computers really do this efficiently? And well, the modern choice, and I tell everyone, is Python. Python's the modern choice for a lot of these applications and more. It is crazy. So from simple like clustering that I have there, simple problem, you have a bunch of points, try to group them together, to say, give an approximation to the two-dimensional Navier-Stokes equations. That's for you, Manny, Mr. Physics Man. So this is just going to be really quick. I wanted to have 3 applications, but I narrowed it down to 2 because I think they're very easy. We all heard of linear regression if you've taken freshman stat or looked at machine learning stuff. So we'll look at some applications of linear regression and like how computers actually do that for some of our basic stuff. And this is a new application that I've been getting into in like the last couple of years, low rank approximation. How can I take large data and just break it down into like as much information as I actually need? So, like I said, a lot of these problems are based in optimization, okay? So, regression, find a line, plane, curve, whatever that best approximates the data. It doesn't have to go through all the points, it's not gonna happen, but we wanna minimize something, okay? Likelihood estimation, you have a bunch of observations from some unknown distribution. What kind of shape does it take? How can you find that shape? It's called maximum likelihood estimation. It's another optimization problem in probability and statistics. And optimal control, just learned about this a couple years ago, if you are familiar with, especially so in electrical engineering, we want to find a function that minimizes a bunch of stuff. So this is true of like, say, adaptive cruise control, search and rescue operations, like autonomous vehicles and everything. We had fun with that too a while ago. Optimal control is really nice. And a lot of these sound very simple. You can talk about them simply, but some of them can get very, very hard, especially optimal control problems. Those can get very, very hard to solve numerically, but if you do a bit of grunt work to like pre-process your data, look at your information, think about the algorithms you want to use, you can actually make it easy to work with. And you want to find the best decision. Maximize profit while minimizing costs, or subject to a cost constraint or labor constraint, something like that. We want to find where, like, say, some of these weird shapes, or if we look at contour maps, where we have a max or min. Won't go into all the details, but of course, we know two words mostly if we look at a lot of the machine learning literature: gradient descent. Imagine you're trying to climb down a mountain, you want to get down there as fast as you can without, breaking a leg or something. And it's also getting dark, so you want to get there in the best amount of time. So we want to solve these problems by following this iterative process. Make a guess, evaluate, make a step in the steepest direction, repeat. Do an update. That's it. It's so simple, right? Guess, evaluate, step, update, keep going until you reach a minimum. Until some exit condition is reached. Depending on how you implement this, or how whatever package you're using implements this, could be a variety of things. Residual is small. You're kind of trapped in like a local min or something, which can happen. There are variants you can do this. And this is already implemented in NumPy and SciPy. Like, all the routines are there. You can read the documentation. Give it a bunch of parameters that you want. Do whatever you want. So the simple version of linear regression, we probably see it in like high school or freshman stat. You have a bunch of points that lie on the plane. It looks like there's a linear relationship. What is that linear relationship? Well, there's a way to kind of estimate it. So I kind of give the simple version here. You have a bunch of inputs x and a bunch of outputs y, and they're paired together, x comma y. Yeah, we're back in school, everyone. I also was a teacher, by the way, so this is going to be on the test. So we have a bunch of inputs and outputs. They're paired. And I'm going to build a matrix X. It's called the feature matrix or data matrix. Basically, the first column is a bunch of ones, which will take care of your intercept term. Maybe there's like some shift that you do. And then the second column is just your inputs X, those observations. Now you take all those outputs, toss them into a vector, and now you want to find this best line, y equals beta 0 plus beta 1 x. Those two betas are our parameters. We don't know what those are. We're trying to find it. Well, how do we solve it? It is actually a minimization problem. We want to find the beta, okay, that's the arg part of this argmin, that minimizes this error. So I do this multiplication, subtract it away from the output, and I want to minimize that difference, make it as small as possible. Now, there's a way you can formulate that easily, use this thing called the normal equations, and you can actually solve it explicitly. We can actually do some math, okay? We get this matrix product here, x transpose x inverse times x transpose y. Easy. So why not just do that on the computer? Well, the problem is the inverse, okay? Now, if any of you have taken linear algebra, 2x2 matrices, pretty easy to invert. 3x3, you can do it by hand, but it's not going to be fun. What if this matrix x transpose x is like, 10,000 by 10,000, 100,000 by 100,000, a million by million, large matrices? Well, hope you have enough RAM, and hope that it's well structured enough to do this problem. Because even if you change one entry of that product, the inverse may just blow up and you don't have a stable problem. So this is expensive. Thankfully, the packages have ways to optimize this and make this done quickly in a matter of seconds, or fractions of a second even on a modern computer. So this is already built in. So I have a bunch of points here in blue and not quite Roadrunner orange. Apologies to people that can't quite see that well, but I have a bunch of points and I want to try to find a line that best goes through the data. Well, if I actually did that explicit thing using those so-called normal equations, I get this red line. Okay, good enough. But if I use scikit-learn, I get this green line. Those are pretty close enough, right? The slopes are about the same. You can't really see the intercept, but the intercepts are nearly the same. It does the job. But again, the problem is actually computing that inverse is hard. So when these packages are written and they come from routines that have been around since, God, the days of Fortran. Anybody work in Fortran? Yeah, I mean, a lot of classical numerical analysis books that I've read from like the 70s and 80s, all the routines were written in Fortran, and that was the language at the time. Got ported over to C. then it got ported over to like all of our favorite languages, including here. So like the libraries just make those, you can actually make those calls, but they're optimized. And it is optimized based on the structure of the matrices that are there, because depending on what that matrix looks like, you can have very slick tricks to go from like something that takes n cubed operations to something that's like n squared, or n squared log n even. Okay. Easy example. Easy example. You can do this in a few lines. Documentation's nice. There's a lot of examples out there. Now, my favorite. That's been my favorite for a while. Low rank approximation. So we have a bunch of data, hundreds and hundreds of thousands of rows and stuff, lots of observations. Do I really need all of that to tell the story? Not really. You can get summary statistics, right? If it's numerical stuff, you can get summary statistics. You can kind of get like a distribution of sorts. But what if we're talking about like images, signals, audio, okay? We want to keep enough information to make the source recognizable so that I can still like look from far away and it's like, that's a tree. That's a truck. That's a dog. That's Victor Wembanyama. I can see without having the full story. The question is, how can this be done efficiently? And we want to take as many components as possible that maximize the amount of information that we're given. Independent components. Okay, and so what's done here is this so-called singular value decomposition. Again, won't go into all the details, but basically, I can take any matrix, doesn't have to be square. That's the cool thing about this. I could have like a lot of rows and maybe a few columns. Okay, a tall, skinny matrix, so to say, or a short, fat matrix. The problem with low rank is this. I want to find a matrix X such that that error is minimized. The F there is for the so-called Frobenius norm, which is based on the information, the singular values of this matrix that I'm looking at. And I want to find it so that the number of components is at most R, what I specify. And I can factor this matrix X in this way, U sigma R V star. The U's and V's are called singular matrices, singular vectors, that tell me the principal directions of my data matrix. You know, where is all the information in that direction going? And the matrix sigma, capital sigma, is the matrix of so-called singular values. It tells me what is the corresponding weight in each direction. Now, if you know anything about diagonalization, this looks familiar, but you can't always diagonalize over real matrices. Complex matrices you can, because stuff, read Axler, your favorite text. But you can always do this. You need two sets of directions, so to say, but it still gets the job done. And so that multiplication actually becomes very easy, because you're multiplying with a diagonal matrix, which basically is just like, you know, look at a weight of this column times this thing. You don't have to do a bunch of weird magic. But solving this full problem can be very, very expensive, give or take n cubed. But if you don't need all the information, you just reduce. So I'm going to show an application here. It's just an image compression. Now, this is just a toy example. I'm showing some images here that I've taken and done the singular value decomposition by keeping as many components as I want. And you'll see the full picture come into view. Okay? The cool thing is that in these applications, you can reorder that matrix sigma with appropriate changes in the U's and V's so that your largest singular value comes first, and then all along that diagonal, it just decays. And it's a fun decay, too. You don't need all the information. Maybe you can keep a quarter of the singular values to capture 80% of the information, depending on what your data looks like. So let's start. I like chess. One of my favorite chess YouTubers is Anna Kramling from Sweden, whose father is a Spanish grandmaster. I actually forgot his name. But it's a clip from when she was playing against this mysterious player, Ray Enigma. This is in black and white. 5 singular values right there on the top left. You can't make that out. It looks like, TV static. We still remember TV static, right? You know, people had bunny ears on their TVs. I'm dating myself. Now I'm going to add more. Okay, you can kind of see something there. You can kind of see Ray Enigma's hat there. And yeah, he's actually in one of those morph suits, okay? 20, you can definitely make it out. There's a chessboard. There's Anna kind of there. There's Ray Enigma. And 50, you have pretty much a clear picture. You see, as I add more components, I get more information. But if space is costly, maybe I may just want to keep 20 instead of 50. That's for black and white. I can do this in color. One of my favorite pictures of my family, and you can kind of see that I definitely do look like my dad. A lot of people kind of say I look like my mom kind of too, but I see it more in my dad. But in color, basically what we do is we reduce this to the red, green, blue channels, SVD there, and then glue them back together. 5, you can kind of see my dad's face, sort of, with 5, but you can't make me out. It's, you know, I'm not that important. My dad is. 10, okay, my mom's kind of coming into view. I'm somewhat there. 20, again, we're looking better. And then 50. Of course, with color, you have 3 channels, so you have 3 times as many, but it's still reasonable on a modern machine. And probably one of my favorite recent pictures of me. This is from the first datathon that we had at UTSA back in 2022, 22. I'm explaining to my buddy Liam, like Chris and I's project there, and I make this weird pose. It's just hilarious. But again, 5 singular values. You can kind of make out 3 people. 10 singular values. Oh, there's balloons behind Liam. 20, okay, this is good enough, I think, but if I want 50, I get a bit more clarity. So all this to say that linear algebra is so powerful. It's something I recommend all my computer science and engineering students to take, because especially they want to get into like looking at data and like how the computations actually work. This is a great start. And of course, Python makes it so friendly. I mean, I can't imagine doing this in C++. Oh my gosh, I can't imagine. No, or rather, I can't imagine doing this in like, you know, Commodore Basic. Yeah, I know Basic, kind of. And it is very accessible. A lot of these libraries have like a lot of toy examples, and a lot of our modern world, from like, you know, solving differential equations to looking at data, looking at neural networks. It all starts from simple toy examples like this, and it can be easily picked up. Thank you, guys.
I see Mom in the picture. I see Mom. Really? I think so.
I mean, I'm now as bald as my dad now, so.
But no, thank you so much, Sean. Appreciate you for saying yes and giving this presentation here. Any questions for Sean? Oh,
Yes.
So for the image reconstruction, did you use CNN?
No, there is no neural net done here at all. So every image here is represented as, it could be fed into my workspace as a matrix, or, well, really a tensor. It's a stack matrix, especially if it's in color. 1 for red, 1 for green, 1 for blue. And I use the built-in singular value decomposition SVD command in, I think it's scipy.linalg or numpy.linalg, I can't remember which one, to do the computation to look at how many, you know, get as many components as I desired. So no CNN required here. Now, modern image compression, like say with JPEG, that's done with the discrete cosine transform, which is actually much more efficient than singular value decomposition, because you still have to solve a bunch of equations here, and that can kind of get expensive. I want to say that that's a good question, because singular value decomposition requires about n-cubed operations, and I think a CNN, you still have to like make passes depending on your window size, trying to like do a back of the brain envelope calculation here on how many operations that could take. But that's a good question.
We'll close it out here. Take us home.
Yes. So in the general sense, you know, a square matrix A has eigenvectors. Here's how I always explain it. Eigenthingies, eigenvectors are just reduced to stretching, and an eigenvalue is the corresponding stretch factor. So if you multiply a vector by a matrix A, AV equals lambda V. V is an eigenvector, lambda is corresponding eigenvalue. We don't have that for rectangular matrices, so we have to kind of generalize. So instead of having one eigenbasis, we actually need 2. The left singular vectors, U, which are the eigenvalues, the eigenvectors of A star A, the Hermitian, because in general we want this in complex, so we actually get solutions. And then V is the right singular vectors, A star. So we need two sets of eigenvectors, but those principal directions are indeed corresponding to eigenvectors of the matrices A star, and A star A.
Thank you so much, Sean. So we officially went over. So our live streamer, Adam, thank you so much. Yeah, Adam. So this entire conference was captured live and recorded and will live on the DEVSA YouTube channel. So definitely look for a link for that and our list of resources. We still have 2 books to give away, and our after party is messaging me like, where are the people at? Because they're giving away a Raspberry Pi at the Double Standard. But before we get there, we got 2 books from our 20 years of Django from Paul over here. So let's get these numbers out. Let's get these books out. For folks that do not want to go down to Double Standard, we're still going to be playing the Python documentary here for anyone that wants to check out what Code Repo cooked up there. But with that said, we got numbers.
Does anyone not have a ticket?
Oh, let's get Janetto a ticket. All right, let's go. Let's go. Take us home, Richard.
Okay.
He's.
And then we're going to put all the tickets back in and do the PyTexas.
Oh, we still got a PyTexas ticket to give away. Holy shit.
3 numbers, 235.
235. 235.
Several people go, so we'll get through this quick.
All right, going once, going twice. Next.
204.
204. All right, it's not here. 249. All right, let's keep on going. Congratulations. Thank you so much for coming out and staying to the end. I appreciate you both.
And you have to learn Django now.
All right, last book.
And we got a speaker now for our next Django conference. So great. Yeah, I love it. 215. Lots of 5s today. 215? Missed it by that much. 248.
248.
Oh, come on, guys. Try harder.
Here we go. Here we go.
Oh, maybe it's my fault. 221.
Oh! Hey, the least we can do. The least we can do. There you go, senor.
Okay, so I'm gonna mix.
3-day ticket, 3-day conference, PyTexas.
20th.
20-year anniversary of PyTexas happens in April in Austin. We're gonna.
You into the show, it doesn't give you a 3-day hotel. Okay, I'm sorry, guys.
But let's see who's gonna get a free PyTexas ticket.